Bonjour, bienvenue à tous. Hello, good morning to everyone. Welcome to guys online and guys on site. I think we are not yet ready on site, so sorry for guys online. We have to wait a little bit more. I'm Eric Gonon, I'm the CTO for Digital and App Innovation, Field CTO for Microsoft France. And I will be with Alain from GitHub, it's Field CTO too, and with Jay Schmelzer, Microsoft Corp, it's Director in Program Management. Come on, don't be shy. There are a lot of space here in front of the stage. Agenda for today. First, we will have a quick introduction about platform engineering, about 10 minutes about what is platform engineering from our point of view. And then we will have back from GitHub Galaxy. GitHub Galaxy is an event that we delivered 1 month ago, explaining all the new features that we have in the GitHub space. And then Jay will explain in deep Microsoft platform engineering. At 11 or around 11, we will have a short break, about 15 minutes. And then we will be back with some demos about products to implement platform engineering and some overview of GitHub platform engineering too. For those who are online, you can ask questions with the Q&A chat in Teams Live. For those who are on site, you will have space to discuss with us during the break or during the lunch. And then on the afternoon on site, you will have 2 hands-ons. The first one is for ops, the second one is for devs, because platform engineering, it's for both devs and ops, but it's not exactly the same slide of the same coin, so that's why we have 2 different workshops. But hopefully, because it's workshops, it's publicly available, so you can play on your site. The other workshop, we will share the links with you this afternoon. And then at 5, we will have a cocktail where you can bring new questions or interrogations that you will have with experts that you saw in the hands-on or during this morning. Are we ready? Yes, I think we are 100% ready here on stage. So the first slide, it's somewhere DevOps is dead. Yes. It's not that it's dead by itself, but if we see DevOps maturity that we have right now, around 80% of companies are on board in DevOps story. So DevOps, it's quite mature discussion, but when we ask if the dev velocity is still a topic with DevOps, it's not true. We have some sort of plateau with the DevOps velocity since last year. Thank you for the timer. It's a bit of is it a countdown? Okay. A little bit strange, okay. So DevOps is dead because DevOps it's not ready yet for at-scale DevOps. DevOps it's fine for startups, it's fine for teams, but at the company-wide side, it's not really true. DevOps is not working well. But long life to DevOps, because DevOps concepts are very good concepts. With DevOps, we are able to bring more velocity and ship faster new apps or improvement to apps. And we have just a little bit another point of view. Instead of saying we have dev on the left side and left side, and ops on the right side, we have more something called inner loop and outer loop. And why DevOps is useful? It's because we are able to scale DevOps at scale with the platform engineering. Platform engineering, it's just how I can support all the DevOps stuff. That's the magic. We can summarize platform engineering as a discipline. It's really a discipline. It's not a tool. It's not an endpoint. It's something that we have to embrace. It's a discipline of designing, building, and operating capabilities to maximize dev freedom. That's the key point. It's dev freedom. But why dev freedom? Because we have to minimize the dev cognitive workload. It's too complicated today to be a dev and to handle tons of technology. So you have to bring lot of freedom and reduce the cognitive load and provide some guardrails to your developers to be sure that they will be comfortable with the way they are doing some software development. And the ultimate goal is just provide software delivery at an high velocity speed. That's the idea. It's some sort of reboot of DevOps, but we reboot DevOps at scale. And platform engineering, by itself, it's a discipline, as I said, and it's something like a product. So you have to think your platform engineering in your company as a product itself, and not as a bunch of products or services. It's a product. And when I say product, you have to understand your customers, create features and maintain features, deprecate features, and so on. So it's really a product. If you are a developer and you don't have the right velocity, maybe it's because you have a developer work environment limited. The onboarding is complex. If you are a developer on multiple projects, you have to switch between projects, and each time you have to switch, you lose time or you have a cognitive load unuseful. So that's something that can break the velocity of developer. We have different projects, and each project maybe is not at the same level of maturity regarding the languages or IDEs and stuff like that. Maybe you have limited access to dev environment or to pre-production platform and stuff like that. So, or maybe just performance issues, but you have some things that will break down the dev velocity. And on the opposite, on the application runtime environment, maybe you also have complex configuration to handle, because today you have to handle networking stuff, firewalling stuff, cost with the FinOps stuff, and so on. And maybe you have to manage tons of different technologies. And that's not the earth of the developer. Developer will not manage technology. Developer will solve business problems. That's the goal of a developer with technology, like languages, frameworks, and stuff like that. But maintaining different SQL servers or no SQL servers version and SDK, nothing to deal with the velocity. So complex configuration. Second stuff, like a lack of self-service deployment, because if you are a developer, you don't want to pass through an ops team to deploy something in production or something in non-production environment. It's too complicated, and because it's too long, you will have latency between something in production and something that you have to rework. And long wait times, it's just because you have a chain of tools and you have to speed up this stuff. But because it's something in production, you have to balance between agility of developers and security of the company. So that's why we have two kinds of profiles. We have the developers on the left and platform engineers on the right. Platform engineer is somewhere a new kind of ops, but it's not just ops. It's more than ops. It's I have to manage a product, so I have to embrace some developer mindset inside my operation staff. On the other side, you have to improve the collaboration between devs, provide flexibility, and ultimately have good productivity. That's on the developer side. And on the ops side, you have to provide security, of course, but also governance, because that's a key point. If we would like to remove cognitive load from your devs, you have to simplify the path. But simplify the path, but be sure that the path is the right golden path. One key is standardization. Standardization is some sort of blueprints, but blueprints, it's not something that you have to comply with. You have non-negotiable stuff, you build on that, and then you have golden paths. But maybe sometimes you will be able to be in a non-standard stuff, but in that case, you will have more load on the developer side to manage something that is not standard. And cost management, yes, because you have to improve the cost management stuff. Today it's a discipline, it's a FinOps discipline, and it's not something outside of the developer lifecycle. It's inside the developer lifecycle, but maybe embed in the platform instead of having a new technology to manage. The first point I say is you have to start right. That's key, but you also have to stay right. That's another key. And how can I stay right if I don't have time to manage external requirements like regulations, stuff like that? That's the idea of the platform. The platform will provide for you all the stay right stuff, and you will be sure that you will comply with the internal rules when you evolve or when you maintain in production your app. All that stuff must be done in self-service because you don't want to have a long chain between teams and with tickets and stuff like that. So everything on your end. As a summary, platform engineering, it's providing a lot of freedom through a supporting platform. Platform engineering is not a locked-down platform where you have just a playground and you can just do some stuff inside the playground. That's not the idea. It's a supporting platform. We provide you tons of stuff, and then you build on top of that. That's the idea of the platform engineering. At the end, it's a trade-off between freedom and guardrails, and it's just a trade-off between devs and platform engineers. We can summarize the platform engineering as multiple layers, multiple building blocks. If you are able to implement all that building blocks, you will have a beautiful platform engineering stuff, but again, it's not an ultimate goal. You have to create a product, so you have to analyze the needs for your customers, internal customers. When I say customers, it's engineers. Engineers, maybe it's a developer, but maybe it's an AI guy, maybe it's a data guy, maybe it's an ops, maybe it's a security guy, engineers. And you have to provide building blocks, and then you have to provide the application platform where the application will run, and that's where you will provide governance. And then you have golden paths with templates. Plus, you must add developer self-service capabilities. Tons of capabilities as a developer staff, not just a dev portal to be able to grab some services, but also metrics, identity stuff, orchestration, and so on. And you will find all this information from today in this short link, aguerri.ms/platin-ng. It's a blog post from Amanda Silver, our VP from the developer division, and the main idea is that we will try to summarize all the stuff inside the blog post, and inside the blog post you have link to the documentation and Microsoft Learn stuff. Now I will invite Alain on stage for the second part of this morning. Thank you.
Thank you. Thank you, Eric. Good morning, everyone. How's it going? It's sunny outside, right? It's been a while. I mean, it's so excited. We're like so sunny, and then we are all inside and the dark. Such a good idea. Anyway, let's have fun. I wanted to show you what we've been releasing or what we've been announcing during our conference, GitHub Galaxy. So we had a roadshow for Europe. The Paris stop was sometimes in May. And basically the theme was how to move fast and safely at the same time. And this is a bunch of things that we are working on that we want to share with you so that you know a little bit what we're going to deliver in the next couple months. So move fast and safely, we're going to start with move fast. 3 different themes over there. Optimize operational efficiency, accelerate productivity, and reduce technical debt. So that's the 3 themes for the features we're going to release over there. Obviously, we're talking a lot about Copilot these days, right? Who is using Copilot already? Yeah, almost everybody. Cool. Nice. Hope you like it. We're going to make it even better. One of the things that we want to do with Copilot is to attach it a lot more with the the native objects that you have in GitHub. So the issues, the pull requests, all these things. Right now, Copilot is really in your IDE. That's where you're coding. But what happens when you are submitting a pull request? Like, how can we speed up the code review process, for instance? That kind of thing. So that's part of the things that we're going to look at. We have new stuff coming in the next couple of months around that, and I think it's going to be really exciting that before even submitting your pull request, you're going to get a review. You will have more confidence with the codes you've created, and that's going to speed up, the discussions with your peers. We already are able to summarize the pull request, so providing an outline of all the changes within, so that when you have to do a code review for one of your colleagues, you don't start with like a very small description of what it is and you have to guess. So we are helping out over there. Another thing that we have announced, it's very, very exciting, it's a Copilot extension. So how do we bring Copilot to basically your ecosystems of tools? So you're working with a lot of tools on a day-to-day basis, and it's good to be able to retrieve some information about your current configuration, for instance, your database, and to provide that to Copilot so that Copilot can generate some code based on that knowledge of what you have in your runtime environment. Copilot, is based on an LLM. LLM has been trained on something, but that's something that's existed like maybe 1 year ago, 2 years ago, and it's never exactly your environment at the given time. So with Copilot and the extensions, for instance, we have a data stacks extension here, and you can ask, tell me about the databases we have in our environment, and Copilot will be able to retrieve that information, and you can continue the discussions like within the database. What are the collections do I have? Did I click? No, I didn't click. Let's click that. So yeah, I can ask for about the collections, and so we go deeper. We get live information, and then Copilot is now able to deliver some information or some code based on that. I can go to the next step and ask, how would I retrieve a token, for instance, so that I could create a connection to my database. So all that kind of things can be done with Copilot extensions. We have 16 extensions released already, so it's a preview. It's not generally available, but you can apply to the beta preview. So that are the ones we have now. We have 100 more coming, until our conference, GitHub Universe, that's going to be in November. So 100 more are going to come. And down the road, the idea is to also provide you the ability to create private extensions so that you can create your own extensions in your environment for your own needs. So it's very exciting. It's not only gives you, the ability to provide information to Copilot, but also it gives you a new way to interact with your full ecosystem of tools without leaving your IDE. Like, you don't have to go to data stacks. You don't have to go to all these different tools to get some information. You can just query that with natural language and right into your IDE. So it's a huge time saver, and we're going to keep going in the theme of customizations, customizing Copilot by doing some fine tuning. So if you have like a very, very large repository, or you have like a some kind of very exotic language or set of frameworks, that kind of stuff, we'll be able to learn from that. We'll be able to learn that code. We'll be able to learn what your developers are doing, like what do they do during their pull requests, for instance, what the new code that they are creating on top of these exotic languages or like very large code bases, so that we can fine tune the suggestions that Copilot is making. And so you're no longer relying on the vanilla LLM, but you get something customized to your own needs. So it's very exciting. We're going to start the limited public beta in the July timeframe. So it's really down the road. Still accelerating productivity. We get that build fix suggestions that it's coming as well. I mean, that's already there actually. No, sorry. Yeah, we'll go back on that. Sorry. Accelerate productivity as well. Copilot chat is now available in your mobile as well. So if you want to, solve pull requests or fix issues while you are in the subway and like it's super crowded and everything, like think about your journey when the Olympic Games will be over. You'll be able to still solve issues over there. Code scanning autofix, that's the one I was referring to just before. It's really exciting. So, we have a product at GitHub called GitHub Advanced Security. So the idea is to not only look into your dependencies, but also your secrets, like making sure that you don't have secrets stored in your code. But there is also a very cool tool, based on a technology called CodeQL that's looking into your source code and finding security problems. And until now, what we were doing is that, whenever somebody was introducing a problem in the code, we were providing an alert and explaining basically what was the problem. So we were giving some information to the developer about, what's, for instance, a cross-site scripting problem. So providing a lot of education, but it was still, a lot of energy for developers to, what is that kind of problem? I've never seen that. I don't know how to solve that. So, all that kind of things were taking a lot of time for developers. So instead of just giving an alert and giving some education, we decided to go to the next step. And every time we're seeing such a thing now, we'll be able to still alerting, still provide you some information about it. But right under that, we're going to provide you the solution as well. Right, so Copilot here in the background is looking at the problem, is looking at the data that's been raised, and gives you, the recipe for the solution. But it's also creating the code that would provide the solution. And here it's like using a new package. It's changing the code also to use that new package in order to fix the problem. We're doing that already for Java, JavaScript, TypeScript, Python. And we are adding on top of that Go and .NET as well, C#. So once you have that, you can either edit that suggestions if you want to refine that. You can commit it. You can, if you want to dismiss it, you can do that as well. But I mean, most likely you want to commit that fix, and there you go. You found it, you fix it right away. So pretty cool. You can merge the pull request after that, and off you go, and it's fixed. We say that found means fixed now. Another thing that we are working on is to find generic secrets. So with GitHub Advanced Security, we've been able to find well-defined secrets. That's what we call tokens, API tokens, like the ones you're using for Azure, or like the personal access token from GitHub as well. So all that kind of stuff, we are able already to find them. We allow you to create some custom patterns as well. And we've used AI to help you generate these custom patterns, but we want to go to the next step. And we want to be able to, without any configuration, find, strings that look like secrets. And, with AI, we have a good technology to find these kind of problems and to determine that a string is most likely a secret. So we're going to do that. We think that is going to be very helpful, and to have that mix of power without any configuration, so that you can find things that have been buried into your code for like maybe sometimes years. So we have the ability to go back in the history of your repositories, and even if somebody has buried a secret and that secret is still available, we'll be able to find it and to alert you on that, so that you can do a remediation. All right, so that was the move fast. The second half is move safely. So how do we help you with a more flexible governance? We have customers now with thousands of organizations and tens of thousands of repositories. When you have to set up a new rule about that, we were talking about platform engineering and stay in the in a good pattern, you need to have some tools to apply these new rules very quickly. So that's part of that. Hence visibility, you need some reporting, you need some ways to know by numbers if you're doing the right thing or not. And deliver enterprise-grade features, because you have more constraints in terms of security, authentication, reporting as well, all that kind of stuff. So first thing is visibility. GitHub Actions is the #1 CI tool on GitHub.com nowadays. And we know that we have to do a much better job for reporting on the activity of your actions workflow. So we're creating that new dashboards where you'll be able to see workflow by workflow, the number of minutes used, the number of elapsed time, but also consumptions of runner minutes as well. So all this kind of information that will help you figuring out that something is going wrong somewhere, or maybe some workflows are not optimized for speed. We're doing the same with Copilot. Copilot is becoming a great success. A lot of customers, a lot of companies are using it. But then it comes down to, how do we use it? Are we doing a good job at using Copilot across our team? Do we have people, with better way of using it that could teach to other people in order to increase productivity. I mean, we have people coming to us and say, hey, help me teaching my users, my developers to better use Copilot because we know that it's huge efficiencies for the whole company. So we need everybody to be using it the best way possible. So with the metrics, we'll be able to understand who is using what. It goes down to the team level, so it doesn't go down to the individual for safety reason and privacy reason, but still you'll be able to find the best teams and make sure that they get great values out of Copilot. We now have a lot of products in GitHub, so you can think about Copilot, of course, GitHub Advanced Security, you can think about GitHub Actions, GitHub Packages, and larger companies, usually you have some budgets, you have some what we call cost centers, so one division have their own budget, and they want to pay only for what they use, and they don't want to pay for the other team who might be using different products or have a lower investment in CI, for instance, but more in Copilot. So in order for you to be able to tag each team with their own consumptions, we've created this budget where you'll be able to say, all these repositories are mine, and I want to pay for all the consumptions of the developers who are touching these repositories. And that's my budget, that's my team budget, and I'm going to pay for that, and I'm going to let the other ones pay for their usage, so that there is more freedom for adoption through the company, but still, we keep things separated. So it's very interesting. So that's available now for new customers, and the current customers are going to be migrated over that in the next couple of months. Push rules, that's something new, very interesting. So for the longest time, we were letting people pushing whatever they wanted, and then making checks after that. So we created, we started by creating what we call push protections for secrets a couple of months ago, so that whenever a developer was pushing a commit with a secret inside, we will be able to say, no, we don't accept your commit, so that you need to fix that locally on your machine before you can push again, so that a secret was never shared with the rest of the team, because as soon as it's shared, that you need to do a remediation. You need to go back to your systems, you need to rotate that secret, you need to do a lot of things. That's very costly. So push protection, we were preventing the secrets to be shared, and so the problem was never happening. But we've been going further now, and now you can implement some push protection based on paths, based on extensions, based on the number of files or the size of the files, so that you prevent people from pushing binaries, for instance, all that kind of things that you don't want to pollute your Git repo, for instance. So it's going to be very interesting to be able to have these safeguards before the commit and not after, so that we stop spending some time remediating things. We tackle the problem up front. Likewise, we've created also the rules for the branch protection. So you used to be able to have some rules in your repository to protect some branches, but now you can centralize these rules and decide to apply them across your full repositories. And you also are able to tag now your repositories, and you can have like custom properties. So you can say, this repository belongs to project X, Y, Z. And so then you can say, okay, all repositories belonging to project X, Y, Z will apply that set of rules. All right, so that's in terms of governance, it's centralized, and you apply broadly based on custom properties, so it makes it a lot easier to target a subset of repository within your organization. Another cool feature, like we've been asking that, or you have been asking that for probably 10 years already. So we have in GitHub, if you are an enterprise customer, you get enterprise. Within that enterprise, you get organization. Within that organization, you get teams. And things about the platform engineering team, for instance. Well, they might want to touch every single organization. And right now, you have to redefine that team per organization, which is very cumbersome. With that, you have a team at the enterprise level. You define it once. You reuse it through the organization as much as you want. So it's in terms of simplification, that's a huge improvement. So that's going to really make your life a lot easier moving forward. Another cool thing also from a security point of view, I don't know if you've got that stuff. There is a trend called attestation. There is a framework called SALSA, the A standing for attestation. where basically you stamp every build you've created so that you avoid people tampering with these builds and like injecting things and making that available to other people and with some not too cool payload inside or content inside. So in order to avoid people tampering with builds, we've created this attestation feature. It's a standard now, so that whenever you're building something, GitHub can say, this is a list of components that are inside. And later, if you're reusing that package, you can verify that the content of the package matches what has been built. And you get that for free with GitHub runners. There will be a stamp on every packages that you are producing. It's already the case on NPM. So if you're using GitHub runners to create NPM packages, you will have an attestation with that, so that consumer of these packages can verify that verify the integrity of the package if you wish. It's a little bit like an SSL certificate for packages. So that's very interesting. More and more companies are going to be required to use these packages or this attestation rather. So keep an eye on that. You will hear a lot more about that moving forward. We're going to try to democratize that feature, because in terms of guaranteeing that open source is safe, that's going to be very important. Sorry. Last thing, one of the last thing rather, more reporting for GitHub Advanced Security as well, so it's that you better understand what's going on in your environment, like what are the alerts, what are the secrets that have been leaked, that kind of things. And that's it. Thank you.
Thank you, Alain. What a bunch of cool features. So right now we will understand how Microsoft is developing and maintaining the engineering platform. Please welcome Jay Schmelzer from DevDev.
Thank you.
Thank you, Jay.
Thank you. Good morning, everyone.
Morning.
There we go. That's what I was looking for. So yeah, my name is Jay Schmelzer. I'm one of the directors of product in the developer division, product engineering team at Microsoft. Really excited for the opportunity to spend some time with you today to talk about this kind of emerging or sort of been around and finally been named over the last couple of years trend of platform engineering. My role at Microsoft, while I've been in the company for quite a while, the last 6 or 7 years, I've led a team that's primarily external facing, so customer facing, where we look for opportunities to go and engage deeply with you that are doing interesting things to help you be successful, but also really understand what you're trying to do and how the products and services that we're creating at Microsoft are, or maybe are not, helping you to be successful. So one of the things that my team has been working on for quite a while is this notion of platform engineering. We definitely started it long before it had a name. We were doing it internally before then as well. And so excited to spend some time and just sort of share what we've been learning and then talk about how we kind of our vision for how to help kind of you accelerate that journey going forward. Just for context, quick show of hands, how many folks are personally or your organizations have been investing in this notion of platform engineering? Okay. How many of you would say that your teams have been investing and are fairly mature in the notion of DevOps or the practices of DevOps at this point? Okay, a few more. Great. Well, so hopefully then what we'll be able to do is kind of give you a little bit of that context. So what we wanted to do today is really spend a bit of time and just talk about, Eric did a great job of kind of setting the stage for it, but really spend a little more time and go into a little more detail of what it is we're all trying to achieve. And one of the things we will do is spend some time and talk about the journey that we have been on at Microsoft to create an engineering platform for our organization of 80,000 plus software engineers across lots of technologies and products. We're going to try to manage us to, a little bit right around 11 o'clock. We'll take a break, come back after the break, and we'll spend about another 45 minutes or so going into more detail of the actual product vision and do some demos and things like that. So a little bit of context, and then we'll switch to the other part. So Eric mentioned this, but when we think about, DevOps and we think about kind of where those practices are, right? It's something that's been, maturing a lot, but really there's still a lot of challenges that we have to tackle, right? We have these central teams that are being asked to do more and more in terms of the guidance they provide, the validation and ability to really have the organization feel confident that they're adhering to compliance and regulatory requirements and those kinds of things. That knowledge is often really difficult to find, to have available. There's a lot of just sort of tribal knowledge or networking that comes into place, right? Around what it is, who do you need to talk to for this? Which group, which person, what permission do you need, those kinds of things. And a lot of the things that people are trying to achieve are really creating more, standard environments, standardization of how these things are done so that we can kind of learn from and develop a best practice and then kind of rinse and repeat that across lots and lots of organizations. And the list of things that these teams are being asked to manage is quite large in and of itself. But that all exists, and then we throw on top of it this rapid rate of innovation that's happening and all these additional complexities that are coming out, and that we're asking development organizations, infrastructure organizations, and even platform engineering organizations to be able to manage while still responding to the increasing demands of your business partners, of the value you're trying to create and the time to market you're trying to generate. That little bit of an eye chart to the right, and I have joked with my eye doctor before that we should just replace the standard, letter thing with something like this and see if you can actually read it. Your eyes are probably pretty good. That's kind of the current state of the CNCF projects, right, for cloud native. Just one segment of the broad scope of what we as application developers are being asked to manage. And that just continually adds and adds to this. So how, right, can we realistically expect that our software engineers, our infrastructure teams, are able to both keep up with all of these changes, rapidly deliver value and meet the needs of the businesses they're being asked to support, and provide all of the governance and those kinds of things, while at the same time maintaining some sense of personal life and balance to be able to do things, right? So you're not spending every beautiful day stuck in a dark room, right, trying to learn more about the technologies you're being asked to deliver. So to try to really bring this to something concrete, this is a little bit of a story that my team had the opportunity to observe with a customer that we've been working with. Turns out this is a financial service company, or in the financial service industry, based in predominantly New York City in the U.S. And while we were talking and working with them about what they were trying to achieve, the primary leader of the initiative at the customer shared this story with me, and he shared it with me in the form of an actual email thread. He redacted the right things, but he shared with me the journey this poor engineer at their organization went through to try to just stand up a cloud-based environment to start testing the migration of an application. That's all they wanted. That's what they were asked to go do. And the journey that they went on was they started with, okay, who do I ask? Right? In this case, the customer was using Azure. So like, how do I get access to a subscription? Oh, well, you need to go to this infrastructure team, it was start by sending an email to this team, right? That team replied with an email to a link that said, please fill out this form. They filled out the form. Well, actually, they didn't even have access to the form. They had to go figure out how to get access to the form. They went to the security, a specific user access or permissioning team who said, oh, we'll just show up at our weekly office hours and we'll get you figured out, right? Which was like a few days later. They finally did some of that, and they kept going back and forth and back and forth. And this email thread bounced around between all of these different teams within the organization for about 5 weeks. Just kept bouncing back and forth. And finally, that individual engineer, right, kind of threw up their hands and said, okay, I'm gonna make my last attempt here. I'm gonna go for something that I know isn't gonna work, but I'll try it. I'm gonna send an email to the head of our security group. Now, why did you think that was never gonna work? Well, because what do we all know about security? They just say no, right? Like, what did you wanna do? No, you can't do that, right? It's kind of, security and lawyers are kind of the same, right? They all just tell you no, right? That's kind of their job. Well, now it turns out the security lead at this organization is the individual that I'd been working with, right? That my team had been working with to enable an engineering platform. He had this vision, right? Where first he had enough self-awareness to realize he was the most hated individual in the company because all he did was say no, right? But he was always trying to enable people, right? And he was just saying, look, I have a team of people and we're constantly going and understanding and investigating and analyzing the different capabilities that our engineers want to do. And we're developing this guidance, right, to enable them to go provision these capabilities, right? Now, like the best he had at the time was a set of Confluence pages, right? I believe that what he showed me for provisioning an Azure App Service was about a 12-page set of Confluence pages on the various controls and things, had snippets of infrastructure as code artifacts that you could paste into, an ARM or Bicep, or actually in their case, Terraform template, right? But it was a very manual process, and you had to find it, and you still had to go through these other things of just getting access to it. He's like, I want to make this so that it's just simple, single-click deploy, and these engineers can get going, and we have confidence that they're doing it, following our guidance, following our best practices, and so forth. So when this engineer finally did his, okay, I'm going to take a last attempt and send it to the security lead replied back immediately and said, yes, here, this is the very simple, I think it was like 4-element piece of form, right, essentially, that person needed to fill out, right? Essentially, what's your cost center, what's the name of the project, who are the project leads, and maybe I think they actually were at that point also gathering is this a place, do you already have a code repo that's associated with? That was it. And then within minutes, got a reply with, here's your subscription, here's your resource group, and oh, by the way, here are a set of, they're an Azure DevOps customer currently, like here's a set of Azure DevOps pipelines that are already pre-configured with the basics to publish your application to that new environment. Have fun, let us know if you have any problems. Amazing, right? From 5 weeks of getting nothing to going to the one person you thought could never possibly help you, right? And suddenly minutes later you had a solution. That's the kind of thing that we want to be able to achieve here, right? So Eric showed you a much more digestible version of this, but my peers that are working in platform engineering are rather verbose. So at the end of the day, our belief is that, platform engineering really is a practice, right? It is not so much, there are products that can and will help with and facilitate this, but at the end of the day, it's a practice. The changes are very much like what we've all gone through in our DevOps journeys, right? Where it's a lot about, culture. It's a lot about process and it's a lot about the people and then the processes that support them and then the products that support those. Platform engineering really builds upon that. It does have, a very specific focus around that developer experience. I do believe that's one of the things, hopefully, as the developer division at Microsoft, we can really bring a focus to that developer experience so that you as a developer feel empowered. You can go get these things to happen in a self-service way without having to go through, multiple steps of approvals and things like that. We can build those in. But it's also there to support those kind of platform folks, whether it's the collection of folks across these different responsibilities from security and identity and networking and monitoring and so forth to ensure that the practices they're trying to establish are being implemented consistently and repeatably for each of these solutions. And lots of other things we'll talk about kind of go into this. So when we think about the various components here of a journey, right? Again, going back to some of what Eric pointed at, number one is thinking about this as a product, right? It's a product that is internally likely, most likely being, targeted and consumed internally within your organization by your developers, but really thinking about it as a product. I'll talk about this quite a bit when I get into sort of our learnings and observations from our internal Microsoft journey there. It's thinking about not only providing these self-service deployable environments or environment deployments as a service, but really gathering that inventory as well and having a really accurate, up-to-date understanding of what is deployed across your organization. One of the other areas that my team and I work with customers on is the notion of app migration and modernization. I won't ask for a show of hands, but I would say one of the first things that I ever encounter when I work with a company that trying to do some app migration is, what do I actually have? What's actually running in my estate, right? What are these different servers, right, that are out there? What are these different VMs? What's running under somebody's desk we didn't know about? Can I turn that off? I don't know. Is the business going to collapse, or is that not used anymore? So really gaining an accurate inventory and a confident inventory of what's deployed, who are the owners of it, and so forth. One of the things that we try to do is really look at where are the opportunities to most immediately and significantly reduce the complexities, the time developers spend on things they don't want to be spending their time on. So we often refer to that as the toil, right? How do we reduce those things? Another way that my boss likes to describe this is, how do we enable everyone, how do we enable developers to stop spending time on undifferentiated heavy lifting, the things that aren't providing unique value to their organization, the things that they as developers are not uniquely suited to do, right? The phrase that we use quite a bit of, like, how do we enable developers to spend their time doing the thing that only they can do, right? Writing the code that only they can write, right? Implementing the logic, the custom rules that only they can be aware of, that only your organization understands. Optimizing for self-service experience, and then this notion of paved paths, right? So really one of the places that we see customers customers attaining as they get mature here is having a set of paved paths, golden paths, the prescribed ways of doing this kind of top to bottom. And I'll talk a little bit about where we are at Microsoft with that and sort of how you could think about the levels of that path. One of the things, well, actually, we'll talk about it as part of the Microsoft journey. So let's talk a little bit about kind of the journey we've been on at Microsoft. And this is a journey we've probably been on, I'd say it's probably almost 12 years now, really, from when we really started. It started as our journey around this kind of the notion of DevOps, and maybe the last 6 years has been really pivoted more towards this notion of platform engineering, which of course we did not call it that then. And matter of fact, it was one of those conversations that I went back to our One Engineering System team, the One ES team, and said, "You're doing platform engineering." They were like, "What's platform engineering?" What you do every day. You're the ones doing it. One of the things that has been key to our success was we started kind of from a grassroots standpoint. We started with a few teams that really had the vision for being able to do things more efficiently and more productively. But it took off when Satya Nadella, our CEO, kind of started making statements like this, right? Essentially giving us the top-down push, right? From his levels, essentially saying, hey, there's nothing more important in my mind than investing in our own engineering productivity. We have 80,000 plus software engineers. Why would we not be investing in making sure that they're being as effective and productive and efficient as possible? And in fact, even saying, hey, I don't think he would make this statement today. I think today he would say, I would any day of the week trade off security for features. But productivity and those things all go hand in hand as well, right? So the engineering system team, I mentioned, we have in our creative naming, the Microsoft internal engineering platform is the One Engineering System, or One ES, and the team that maintains it is the One ES team. Their mission, their charter is to provide this standardized, secure, scalable foundation for software development across all of Microsoft and all of Microsoft's teams. And Microsoft is not a single stack technology organization, so we'll talk a little bit about how we manage that. But they really have this aspiration of being, the source of productivity for the organization. We had three primary kind of traits, or that we think there's three main aspects of our engineering platform. One is community, right? Breaking down those silos, creating the ability for everyone in the organization to collaborate, leverage their unique experiences, points of view, as well as expertise, right? And create a thriving organization. We want to be able to kind of create an integrated experience that really reuses things both that we build internally, but also are available externally. And finally, putting security, privacy, all of those things central to the experience. One of the things that I really believe has been key to the success for where we're at in our One Engineering System journey is that we focused on what are the things that people are struggling with? Where are the places they don't want to spend their time? And how do we just make that not an issue, not something they have to think about? Inside Microsoft, for every service that's in Azure or M365 and every product, we have a set of what we call the fundamentals, right? So these are the things that we believe must be true about anything we do, and it encompasses security, privacy, governance, all of those kinds of things that you could think of. We used to manage it, as you would expect. It was the spreadsheet that was this big scorecard, right? Service down one side, capabilities across the other, and everything was red, yellow, or green. And depending on the time frame, 4 to 6 weeks, you would come in for a fundamentals review. This was not a meeting you ever wanted to be part of. Scott Guthrie, who is our executive vice president for the cloud and AI team, right, runs Azure amongst other things, the infamous red polo shirt guy. He is incredibly detail oriented. He is really good at asking precision questions. So he would have this day-long meeting every 4 to 6 weeks going through fundamentals. And also I should share Scott's days, minimum 8 hours, they can go 16 hours, right? So he's going to stay there and he's going to go through that stuff until he's satisfied that he understands where you're at, that you understand where you're at. So if you're yellow but really red, he's going to figure that out, right? And so that was just that was not something you wanted to do. Well, the One Engineering System team came in and said, okay, what are some of the main areas people are struggling with? Can we just take care of that as part of the engineering platform? So that teams that have onboarded to the engineering platform, say they've onboarded to the component we call One Branch, which is essentially our governed Git repo /plus CI/CD tools. There's a whole set of things that encompasses from the fundamental standpoint, which if you're using it, you're green. Because it's really now in the control of the engineering platform to maintain that for you. And so that was one of the places where the teams really started seeing value in getting on board with the engineering platform because they saw the work they no longer had to do. And we'll talk a little bit more about that onboarding in a minute. So here's kind of how we think about the engineering platform at Microsoft. It starts with our retail, open source, and what we would call third-party, non-Microsoft built developer products. So again, you can think of things like Visual Studio, VS Code. You can also think of things like IntelliJ. Turns out we are one of the larger employers of professional Java developers on the planet. And so that was a key part of our engineering platform, right? Standard, repo technology. We use Azure DevOps Git repos and GitHub Git repos. Azure DevOps pipelines, GitHub Actions, right? And so forth, all the way down the line. So looking at that, looking at open source, what open source components right, do we use across the organization? Turns out lots, right? How do we get those into the engineering platform as well? On top of that, we then build our engineering platform, our opinionated stacks, for lack of a better term, opinionated configurations. On top of that, we then have the actual app development teams or divisions across the organization who are also enabled to further kind of extend or customize the platform based on their needs, or extend it if there's something they need that's not part of the OneES platform. And you see there's arrows going up and down. So at each of these points, we're asking the question, is this truly unique to Microsoft? Should this be an opinion that's built into our retail products? Should we be contributing into some of these open source components we're using? For an app development team, a product team, is it really unique to the needs of Windows or Office, or should that be just something that's available to everyone? And so we look at pushing those things down. Part of what enables us to do that is by taking an inner source approach to this, so an internal open sourced approach. You kind of think of the OneES team as the maintainers of the Microsoft engineering platform, significant contributors, but not the only contributors. Any engineer inside Microsoft can contribute into that platform. And that's also one of the keys that they did, is we went out and looked at what are the characteristics of good, healthy open source projects. How do we mimic those? How do we bring those into our internal systems as well, so that it's really easy for anyone in the organization to understand what's the roadmap for this service or component? What's the expectations of a contributor, right? How do I get started, doing these things? And so that's really what's enabled us to kind of reach a good acceleration or scale of our internal adoption. And again, don't get me wrong, it's not that 100% of every product and service at Microsoft is 100% onboarded to the One Engineering system. It's a little bit of a sort of spiky thing. Some teams are all the way on, some teams are a little bit on, and I'll talk a little bit about sort of how we think about that as well. One of the important things when you're going to embark on something like this, especially when it's a broad organizational event, is like, what are you trying to achieve? Why are you even doing this, right? We talked a little bit about some of the technical hurdles, but kind of looking at the broader scope, what was it that we were trying to do with this engineering platform? Well, for us, there were these four key themes or four key areas that we set out to address 10 to 12 years ago, and they're actually been enduring themes. One is just the health of your organization, the happiness, the talent. We wanted Microsoft engineers to be excited to be Microsoft engineers. We wanted them to tell their friends, tell everybody that Microsoft was a great place to be a software engineer. We'll talk about how we measure these things in a second. We wanted to break down the silos that existed across the organizations. Prior to this effort, each major product division was essentially responsible for their engineering platform. And they were very siloed. The way the organization kind of worked, you typically didn't take dependencies on anybody else because you didn't know, is that going to be an enduring thing? Is some new leader going to come in and suddenly they decide they don't want to invest in that, and now you're stuck, right? So we really wanted to break down those silos, foster better collaboration, and scale that. We definitely needed to increase, the quality and trustfulness of our products, like enable you to really be confident that we were delivering, high quality, compliant, reliable capabilities for you. And we needed to do this at the rate of innovation that our customers were expecting and that the industry was demanding of us, right? We couldn't go on multi-year product cycles. We needed to be able to kind of deliver this continuous rate of innovation, rate of value to you. We describe a lot of that as developer velocity. Some people use productivity. I'm partial to the velocity term because I feel like it really does a better job of articulating what it is we're trying to achieve, right? Which is another key kind of aspect of this, is really focusing on what are you trying to achieve versus the activities people are doing. So we think about some of the metrics or some of the ways we measure it. One of the ways we do happiness is we actually ask our developers. It's actually the most valuable piece of that feedback. Nowadays we do it twice a year. It's a broad survey. It's actually part of a company-wide thing, but if you're part of an engineering group, you have a series of questions that ask you about how you're feeling about, everything from being an engineer at Microsoft to the tools and practices and processes you have in place. We've also really started looking at critical workflows in a developer's life. How long does it take to actually when you're onboarded to a new team or you join the company, how long does it take to actually get an environment where you can start doing work? How long does it take to make that first PR? How long is it taking for PRs to actually be reviewed and merged? How long is it taking for those things to be, prior to that, to be tested and validated? How long is it taking to release something to production? Like, these are measurable things we can look at and have really insightful information about how we can do better. One thing I will say for that we've actually now gotten to as well is across the company, we've started standardizing even on that approach of what are the things we want to measure. We call it Thrive, engineering Thrive inside the company. And so any engineering leader of about 100 or more engineering organization now has access to a Thrive score for their engineering team. That is a combination of a lot of these things, and it comes up with one number and then breaks out into all these different components. Important thing about that, it's not designed to compare teams against each other. It's about that team specifically, right? And where does that team have opportunity for improvement, and how do they track improvement over time, right? Versus comparing two teams against each other. Because again, we have a very broad set of technologies, a very broad set of products, some of which have been in existence for 30 plus years, some of which are 3 days old, right? They're gonna have different challenges and different problems. Collaboration, we talked about it before, it's all about how do we take the best practices that have been established with healthy, strong open source projects and apply those to internal products as well. For quality, looking at things like, mean time to recovery, incident response, compliance response, security response, those kinds of things, from response to actually prevention, like really going along that spectrum. And for velocity, it's, DORA metrics and things like that we leverage a lot of to be able to measure those kinds of things. Breaking it down even further, in each of our products, right, we also then get into further details of what is it that we're going to track, what are we going to look at. And I won't drain this slide, but what you hopefully notice here is that it's less about the things we used to historically track, such as number of bugs, number of lines of code written, estimate, how good are you at estimating, right? Those kinds of things. Still very useful at a team level, like at an engineering leader level. Those are useful tools to understand kind of the health or the maturity of your team. But at an organizational level, they're the activities that people are doing. How do we get people thinking more about the actual results? So when we think about that, it's more about, the measurement of Eric's shirt that says customer obsessed. Well, how are customers using our products? How are they adopting it? What's that funnel look like, right? How are we retaining people? How are we getting them engaged? So when you hear, one of probably the biggest shifts there is when I joined the company 20 some years ago, the numbers we used to share and praise and talk about it at events was, number of downloads. That really doesn't mean anything, right? Now, if you hear us talk about numbers, when you hear us talk about 24 million Visual Studio users, that's engaged users. That's monthly active or monthly engaged, right? So it's a track of number of days of usage over a rolling period of time. So it's much more about what we're trying to do. Fun fact, I know this is being recorded in public, but I'll share it anyway. So when we first started doing this with Visual Studio, how many Visual Studio folks, just out of curiosity? You? Okay. So when we first did this, Visual Studio, client installed product, right? At the time it was many, many gigabytes of download, probably a couple hours of install. When we first started this effort, we realized that about 65% of the people that went through that never launched the product, which was baffling. I mean, you've just invested hours of your time to do something and then you don't want to actually launch it. That's a problem, right? So that's what's, obviously there's lots of dimensions to how we're driving that. But now we see a much, much higher rate of first launch and continued usage there. Throughput for us, that was really about, teasing apart how long is it taking to actually kind of compile our products, which is maybe a unique to Microsoft thing with some of the size of things that we've done. Probably for a lot of you was similar. So like, how long does it take you to actually just understand the quality of an individual build, right? Run the tests and get to a point where we had confidence that we could start using that product internally as our daily use product, that we could release it to you as a customer in a preview type fashion and get as a way of gaining additional feedback and insights. Health, we really pivoted from the classic bug tracking, right? How many bugs did we find? Find, not fix, find, right? To really thinking about things more in terms of your experience as a customer, right? How quickly can we understand that you are having a problem or some cohort of customers are having a problem, communicate that to you, get you back up and running, tracking the support, tracking what that means for live site. Anytime we do have a live site impacting thing, being very diligent about root cause analysis of that, identifying the preventative measures. Now that's one place where we do track activity, right? If we have preventative measures get identified from an outage, we track the timeliness of actually addressing those things, right? And then, employee health, right? Part of that, happy customer base is really like understanding, how are our engineers feeling about just being engineers at Microsoft, monitoring for things like burnout. Over the last several years, something I never thought I would have to think about as a manager, but actually tracking that people are really taking vacation, right? We have vacation for a reason. Maybe this is a US, North America thing, but we saw a real dip in people taking vacations, which was leading to burnout and those kinds of things. So again, thinking about what it is that's specific to your organization and driving you. So how are you doing this today? What's the approach that you're having to take here to actually be able to do this? Well, you're first of all at the core, you're being forced to stitch together a bunch of different solutions, right? So you're creating a dedicated platform engineering team who's out there providing infrastructure and tools and managing the platform. You're trying to create these self-service experiences by consolidating and centralizing some of these things and creating that consistency. And then you're thinking about, okay, what are the unique aspects, right, of my organization? It turns out you all have very unique requirements, but you have pretty common patterns. And so you're having to figure out both of those and manage both of those today. And so when we think about the common set of goals here, what we're really talking about is keeping that developer focused on delivering the business value that only they can deliver, right? Looking at every place that they're spending time and figuring out how do we help them spend more time on the tasks that they're really good at. This is an interesting thing that I've noticed definitely inside of the developer division at Microsoft. We're the developer division, so we think about developers, right? We've sort of matured from, and we think about the software development process historically at its core. So we started as what were really individual developer tools and technologies, right? Programming languages, runtimes, compilers, IDEs. We then, over the course of several years, we got into more of the team aspect of software development with the DevOps suites of tools and so forth. But one of the things that we're still trying to kind of cross into or cross understanding of is that broad organizational aspect of the infrastructure that you need to deploy your application to. So I'll clearly age myself a little bit. It's not too hard. You can see the gray hair and so forth. But prior to Microsoft, I was working for some consulting companies doing custom software development for large enterprises. And even in the most complex environments, going through that, client server to service oriented to web server, like that whole transition, right? Even in those things, like I keep thinking back to, as a developer, there were maybe 3 or 4 pieces of information I needed to know about. It was kind of like, how do I authenticate with the database? How do I locate the database? Okay, now I'm getting into the web world. How do I authenticate, or how do I, find the website or push code? Like, that's about it. I didn't think about firewalls and load balancers and and network configurations. I didn't have to think about that. There was somebody else that did that, and they just gave me the information I needed, right? Now, sure, I probably complained about how slow they were, right? Or how much process there was, and then suddenly I see the public cloud, and I'm like, wow, there's a web page that I can just go fill out what I need, and suddenly I have a database and I have a web server. Still doesn't mean I understand the role of a firewall and a load balancer, and I probably didn't set those things up correctly. So how do we go and rather than thinking that we need to teach developers how to do that, well, how do we allow them to continue on what they do and have the people that understand how to do that, those work, do that and make it available to us, right? We have lots of products and services inside the developer division that get into this space now, whether it's the app service, Azure Container Apps, even things like the Microsoft DevBox, where it's a dual role configuration, and we keep looking at it and going, oh wow, network setup is really hard. Yeah, because we're a developer and we don't do network setup. What does the network administrator's experience look like? How do we get them engaged the right way and create the right experiences? So you keep in developer tasks, ensuring that they're starting in the right place and following the best practices and creating a well-governed, secure application by default. Turns out in all the years that I've had the opportunity to talk with and work with developers, I've honestly never met one who intentionally wanted to do the wrong thing. Intentionally wanted to create an insecure application or something like that, right? But it's easy to when you're not, if you're forced with making these decisions, and by the way, I need it yesterday, right? So, unrealistic demands on them, right? How do we make it so that we can really quickly onboard and offboard engineers from a project? Wasn't me, but one of my team members used to also do consulting, and when he joined the team, he was like, I wonder how many of these prior customers I worked with, I still have access to their stuff because they never offboarded them, right? We joke internally about, we have great human resource processes for onboarding and offboarding employees. We have terrible processes for onboarding and offboarding team members or project team members, right? Simplifying and really making sure we understand what's already out there. How can we go partner with other parts of the company, other teams, and not rebuild the same thing yet again and have 5 versions of the customer definition or API when we don't need them? How can we discover what else is available and understand who's then consuming it, right? So we can have that visibility. I touched on this a bit with the 1ESS, but this notion of like doing all this while retaining the appropriate level of developer flexibility, right? So how do we enable engineers, developers to continue to explore new technologies, new ways of doing things, right? And then appropriately onboard them into this experience. Inside Microsoft, I mentioned the Java thing, so that cat's a little bit out of the bag, as we would say, but most people think, oh, Microsoft, it's easy, you have one stack, it's all .NET and Windows, right? No, yes, there's .NET and Windows, there's now .NET and Linux, there's a lot of Java, there's Go, there's TypeScript, right? There's actually COBOL, there's lots of things like that are there, and so we can't just go lock everybody into one thing, and we can't just ask every team, hey, no, I don't care what technology either you think is best for that workload or that scenario, and I don't care if maybe you were an acquisition and you started with a different technology, you must now snap to the Microsoft one. We kind of did that in the past. That's a bad idea. right? Like we acquired these things for a reason, and then we just basically chopped them off at the knees by making them spend a bunch of time in replatforming. That, now, if you're not in the sort of secure practices, yes, we're going to make you go do that stuff, but it doesn't mean we have to switch all the stacks. So how do we give choice, right? That's also what allows us, that's what I believe has helped accelerate our internal platform adoption, is because we're really clear about this is what we're providing as value in these different platform components, which also means this is what you have to do yourself if you're not going to use the engineering platform. These are the things that you need to be able to be responsible for and demonstrate. It turns out you get enough of those and people really quickly start seeing the value. Cost optimization, obviously, yes, it's important, having visibility into where we're spending time. And then the culture shift, right? That is the other probably biggest hurdle here, is really just like when we went through our DevOps transitions, like really thinking about what's that next cultural evolution. The thinking about this as a product. So the One Engineering System, I've talked a lot about what they do. One of the things they do really well is think about that engineering platform and use all of the same practices for managing that engineering platform that's an internal product that all of our external product teams do. So they do, customer-driven development of the engineering platform. They go out and talk with the engineering teams and understand where are the biggest challenges, what are the things you're looking to actively invest in right now to try to address, right? When they have one, they identify one, then they go out and do some solution hypotheses with them, figure out, is this the right way you expect it to do? They survey all the time. They have, focus groups. They do user studies. They do, all of those kinds of things. They have an internally visible backlog of what they're working on. That's also how they facilitate the inner source development. Like, it's understood, here are the places we're planning to invest. Here's where we are right now. If you need something that's above that line and are willing to contribute it, let's talk, because we can probably accelerate that by having those folks kind of come and join us. Thinking about devs being the primary customer and how to focus on them providing the unique value that they can provide, how to automate all the rest, right? And then really ensuring that all of the key stakeholders for the different things that we're trying to represent, those different areas of expertise, are part of that process, right? So we're not trying to have an engineering platform that are going to represent the security stuff. We have security experts. How do we get them engaged into that so we understand that? How do we do that with operations? How do we do that, through all the operation stacks and monitoring and things like that, right? That's the key aspect of what we're trying to do. And those, I think, are some of the things I see that were key to where we've gotten so far, but are also what I've seen consistently across customers I've worked with who have been successful so far in this part of their journey. With that, wow, I'm ahead of time.
I think I have 2 questions for you.
Okay.
First one, if you can, if maybe it's confidential, can you share with us some figures about the size of one engineering platform?
Oh, sure. That's a great question. And now you're doing it off the spot, so I'm gonna see what I can recall from memory. There's a few dimensions to this. So the Microsoft engineering platform, first of all, I talked about it a bit, but it's a multi-technology stack, right? So we have, if I just think about first things like repos, right? We have a lot of Azure DevOps hosted Git repos. We also have a lot of GitHub hosted repos. A thing that we're probably not proud of, but we probably have some of the largest Git repos. We have some that are in the multi-terabyte, which I wouldn't recommend, but it happens. We talked about the number of engineers, so there's over 80,000 engineers that are actively using at least some part of the engineering platform on a daily basis. We have thousands of repos. We manage millions of builds a month. We do lower tens of millions of deployments. Usually that's actually on a weekly basis. Hundreds of, actually probably millions of tests that we manage now. So it scales. I don't know, you probably have some numbers on your head too that you were thinking about.
That's very impressive. And do you have the number of guys that are managing the One Engineering platform?
Oh, great question. So the One Engineering System team is roughly about 200 engineers right now. So that's the core team. And then there's probably about 60 or so product or technical program managers as part of that. That number is a little bit higher because one of the other strategies that we used on the OneES team was to really partner and collaborate with the other teams, right? So we will go proactively engage with other product groups to onboard them, lend technical program management help, lend engineering help. Now that number, I don't want to be too misleading. So that's the number of people on the core team. The number of engineers actively contributing to the One Engineering platform across Microsoft at any time is probably at least 3 times that. Because you think about those teams that are in the various development groups who have a need that they maybe thought was unique to them, but we all collectively realized was a true Microsoft need that we want in the OneES platform, but just priority-wise don't have the bandwidth yet. They will go and contribute into that. So I'd say it's easily 3x that at any point in time.
And do we have sort of design authority, shared design authority with the inner loop in stewardship model or something like that? Because when you explain the blueprint stuff, you say, hey, we define blueprints, but how can we define blueprints as a One Engineering platform for 80,000 guys?
Oh, actually, great question. So, and I'll probably talk a little bit more about this. Well, actually, I'll talk about it a little bit after the break too, but like the real key that we did, if you think about that layer chart that Eric showed earlier, right, where you start at the kind of a core and you have like, we are mostly just in the bottom 2 layers right now. So we started with the things that were pretty fundamental and consistent across everybody. We only have a few places where we've even gone up into what I would call the app pattern place. And actually one of those, the one that I'm thinking about came out of one of those product teams. So the Microsoft 365 team, specifically the folks that build Teams and the back end for Teams, they were creating a bunch of new microservices. And they were creating them in C# and .NET. And they identified a number of common things that you need to do with microservices, right? So retry patterns, incremental scale back, those kinds of things. And they're like, okay, we don't want each of these teams doing that. So we're going to create our own kind of microservices framework for the Teams team to use when building these microservices. And so they did that. They got all the Teams folks to use it. They evolved it, had success with it. The .NET team saw that. Well, actually, the One Engineering System team first saw it and like, oh, that should be core part of the One Engineering platform. The .NET team saw it and said, no. That should be part of the .NET platform. And so that is what turned into .NET Aspire that was GA'd back a few months ago, right? So that's an example where, that's one example where this whole thing kind of works top to bottom for us. But I think it's also an example of how we approach those things that start getting into more of the, hey, you're starting to hinder my creativity as a developer if you're telling me that there's this pattern that I have to follow. Well, no, you're not, if it's actually your team that's developed the pattern versus some central group. So I think that's one of the places that we've been able to leverage there. That make sense?
Yeah, makes sense. And I think I have the last question for you. It's around metrics and KPIs. Because you explain what we measure, but you don't explain what we don't measure.
Oh, good point. I hinted at a couple of them, but like the things that we don't measure, we don't measure bugs found. Okay, I'm going to tell you my funny story about this. So again, amongst friends, recorded and being live streamed, right? When I joined Microsoft, when I joined Microsoft, we had software engineers and we had software engineers and test, right? Devs and QA. So design it and build it, break it, right? And our test organization, one of the main metrics was how many bugs did you find? And I keep emphasizing find, because nowhere were they measured on how many of those bugs did we actually fix. So we were spending a lot of energy finding bugs, finding issues that we were then never going to fix. And by the way, with these things, not only did we not fix them, we would carry them along. And there was a process we refer to as triaging bugs, right? Where you go figure out, are the priorities right? Which one should we fix? If you weren't going to fix it this milestone, we would usually move it to the next milestone. We'd triage it again, move it to the next milestone, triage it again, release the product with the bug in there. And then what would happen? Well, all these bugs that we didn't fix in the last version, let's reactivate them in the next version, right? And what would happen? Triage, 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 right? So one year when that was about to happen, I looked at this process. I was like, this is just dumb. I'm like, here's what we're going to do. We're going to close all the bugs that we didn't fix when we released the product. You can imagine the test team had lots of words for me. And so I gave them a little bit of a wiggle room. I said, okay, you can keep only the ones that we're going to fix before we do any new feature work, right? No new feature work can happen until those bugs are fixed. So we had a smaller set, right? And the thing that eventually got it through with everybody was, look, if it's a real bug, if it's a real issue, it's going to come back. We're going to find it again. And only this time, we're not going to have the fact that we punted it from milestone to milestone and we shipped the product with it, right? We're not going to have that history around it, so it's actually going to have a better chance of being addressed. But yeah, so that's one. The estimate stuff is another one. We don't, again, at an organizational level, we don't look at, how good you are at estimating how much work there is. We don't look at lines of code. I've always joked that I would rather we see, look at how few lines did you actually need, right? Or how much did you remove because you didn't need it anymore. And I guess the other one, this is always controversial for folks, that we, at least in the developer division, we don't use code coverage a lot. We found that it's just one that, for our use, just wasn't a really useful technique. It was too easily gamed by what folks were doing, or it potentially, complicated our test infrastructure sometimes. So I guess that's the other thing we don't do is we don't, in the Visual Studio VS Code team, we don't do a lot of UI testing, automated UI testing anymore. That's partially enabled because we really have invested in separating the true presentation from the logic, and so we have a more unit testable, API testable way of doing that. But obviously that was motivated because that's a very, very fragile part of the test infrastructure. So, cool?
Good. Thank you. Thank you very much. I think we are on time. Yes, 3 minutes left, so perfect. We will have a short break right now for those who are on site, and you can ask us questions. We will go outside to have the break with you. And for those who are online, you can ask questions on the chat Q&A, and we will be back at, I think, 11:15, because we planned for 20 minutes. 12? 11:20, okay. We keep 11:20, so perfect. So we will have 23 minutes break. Thank you. And we are back, thank you. So this morning we saw a concept about platform engineering, and we just finished on this slide what are the common goals for platform engineering practices. And right now, Jeff Melzer will explain how to do that with our products and services. Thank you, Jay.
Thank you. All right, so I'm still Jay. You're still stuck with me. Yeah, so the first part of the session, we talked a lot about why. Why do we care? What are we trying to achieve? What are some common goals? What I want to do for this section is spend a little more time talking about and ideally showing a little bit of like, well, how? How can we do this? Full transparency, full disclosure. There's a little bit of a vision here, right? So I kind of think of it as we have a number of the ingredients, right, that can contribute into this story. And what we really are working on now is, okay, how do we provide a better way of integrating and stitching those things together? So I'll talk a little bit about why we're thinking about it that way, and then we'll look at some demos of exactly how we can accomplish that. So again, first, when Eric first opened us up, he talked a little bit about this notion of start right and stay right. There's a third category here, get right. But really, to be honest with you, most folks that we talk with are really focused more on these first two. It's really the getting started point, right? And by the way, this is also the technique and the approach we used inside Microsoft for gaining adoption of our engineering platform. It's a whole lot easier to start with the people, the teams that are starting new and have not built up anything yet, right? You don't have to get into the, well, I built a thing, why is your thing better than my thing? They don't have anything, it's a lot easier to approach that way. So when we think about the ingredients, right, we inside Microsoft don't believe it's always going to be, and probably often is not, a single tool, single stack situation, right? So thinking about start right templates and how do you again, first focus on what it is that you're trying to achieve, what's the value you're trying to provide to these teams, and what are the tools and technologies that you need. I mentioned we feel like we have a number of ingredients here, right? So in the dev tool space, we obviously have quite a few. It's sort of our lineage of things like Visual Studio and VS Code and Microsoft DevBox for virtualizing those. GitHub Codebases, Copilot, and so forth. In the platform kind of orchestration layer, again, actions, pipelines. We also have, we'll talk a little bit about things like dev centers and deployment environments, API management. But then you'll have a broad open source community, right? When you think about things like GitOps via tools like Flux and Argo and things like that. Infrastructure as code, same, right? There are multiple approaches to this. And we are trying, I think, very hard to be, well, one, recognizing that and then embracing it. Obviously, there's places where we're going to go do a lot of investment because it's the thing that we are trying to drive. So you'll see us do a lot of investment around things like ARM and Bicep, but we also recognize Terraform is incredibly popular, right? So we want to ensure that that's easy to bring into this if you want to, newer entrants into that space, folks like Pulumi and things like that I think are interesting. On the stay right side, if you get the engineers off on the right foot, how do you then leverage the things that you have to keep them there and maintain those things? So that starts getting a lot more into the actual kind of configuration of the infrastructure, the policies that you put in place, the governance models that you want to deal with around policy and Defender and Sentinel, things like that. GitHub Advanced Security obviously being a big part of that. And then observability is really a huge way of ensuring that you're also staying right? Giving the right visibility into what's operating, what's being used, and so forth. So thinking about that whole breadth of tools and so forth. One of the capabilities that we've been looking at and investing quite a bit is a thing that we call the developer CLI, or AZD. And so this is an approach where we think about infrastructure as code, not from the perspective of the infrastructure so much, but from the perspective of the application developer, right? And so it's really targeted at that developer that is comfortable with command line, a CLI-based experience. This is definitely a place where it brings us a great consistency across the different technology stacks. So while we're seeing some of the newer, kind of .NET developers being more command line based, we know that other stacks, like especially Java and so forth, are very command line friendly. And so what AZD allows us to do is specify, well, you can first specify the templates that you want at an application configuration. We can also add in some intelligence to AZD to actually be able to derive a bit of a template based on what it sees in your current application project and understand what it is you're trying to do. And so this is really taking it everywhere from kind of that local development experience all the way into your cloud-based experience. Now, what I feel makes this really exciting and brings it relevant to the concept of platform engineering is how we can pair that with something like Azure deployment environments. So now Azure deployment environments is really, its mission in life is to be a infrastructure as code orchestrator. The primary scenario that I think about here is around that self-service aspect of both acquiring the space in which you're going to deploy into in a compliant way, and then also acquiring and having visibility to the individual infrastructure elements that your organization wants people to be able to use and prescribe. And do it in a way that can enable developers to self-service without having direct permissions to doing those things themselves. So the scenario I see a lot here is that as a developer inside an organization, I don't have permission to interact directly with the cloud. I can't go, if we're talking about Azure, I can't go into the Azure portal and start provisioning things, or I can't go to the CLI and start doing things because I don't have permission to do that. But I, in the context of a specific project, we want the ability to do that. So what deployment environments allows you to do is create this concept of project, create the identity that has the ability to operate on behalf of those project members to deploy infrastructure. And then you bring in your definitions of what that infrastructure looks like. So it starts from what is the boundary of an environment? Is it I'm going to use Azure terminology. Is it a resource group? Is it a subscription? Is it a namespace in a shared Kubernetes cluster, right? You can specify those. Then you specify what types of these environments do you have? Do you have we'll use the old terminology of, I have a development, a test, an integration, and a production. And maybe the policy applied to each of those ratchets up a bit. A common pattern I've seen amongst a number of customers is, hey, in the development environment, the development instance, we'll have a set of policies that are gonna just alert you versus deny you. Because we don't want to stop the developers from experimenting or realizing, maybe there's something that we didn't get the policy set right. And so let them experiment a bit, but make it really clear that this is not going to be able to move from your development environment to the test or even production environment, because in those places we'll keep them to denied. I've seen other customers that, in the development world will say, we're going to give you, some level of contributor access to that environment. So you can potentially also do some of these experiments with settings in the portal if you want to just try something out. But not going to happen in test or production. We'll only give you read and test, maybe give you no access in production. And the only things that can interact there are these kind of managed identities or principal level things. But then we can go map, right, those project members to that, so that now Jay is a member of the e-commerce project, is allowed to provision things, right, in the context of that project. But maybe as a member of a different project, I have completely different access and so forth. So giving you the ability to start associating those things. And from there, we can also connect that with the Azure Developer CLI, AZD. So AZD can now be aware of the existence of the Azure deployment environments. And so you can have that same experience, that same command line experience, and do both, what we would call a local as me or a remote sort of, escalated privilege or on behalf of kind of flow. And so what that starts to bring together is this, I don't know, I have a little I go back and forth with members of the teams where some people like to describe this as complex. I like to describe it as real. Like this is what the world looks like. As a matter of fact, it's probably the simplest version, where you start seeing how these different cohorts or different roles and members of the team can interact with each other, right? So the platform engineering organization, they're creating those paved paths, those initial environments, those initial pipelines, and you really have the ability to scale the breadth of what that means based on where you are in your journey, where you are, what you're trying to accomplish. So again, if you think about this from the Microsoft One Engineering System standpoint, we started very simple. We started very basic. We actually started with the deployment kit part, the pipelines. And the reason we did that was the thing that we needed to focus on first was really consistency with how the pipelines operated. The teams already had their environments, so focusing on that right away wasn't going to provide us as much value. Now, most customers that I work with, it's the opposite. It's getting the environments out there first, right? What's the dev environment look like? What's the notion of, a common one I like to encourage people to start with is the sandbox, the place where you have a lot more freedom as an engineer, but it is not connected to anything real. It's a completely isolated place. It probably has a time to life set on it so that you don't accidentally end up with something real happening there, right? And then, because that's maybe the first pain point that you have. Those then are published as templates. The way Azure Deployment Environment works, it's all driven by infrastructure as code and config as code principles. So you're going to use your infrastructure as code technology. You're going to check that into a Git repository, and that's going to become the catalog of available infrastructure or available paths. And then you can grant access to those based on individual projects. When a developer is ready to do some work, or a development lead or somebody that's been designated to get the project kicked off, if it's a starting point, you'll figure out which of those patterns and environments make sense for the project and start provisioning it through this tool. And again, I see different levels of granularity here. Some customers take the stack approach, right? So it is, the website with the database and the cache, or the API with the database and the cache, and they have a complete kind of end-to-end stack. Others do building blocks. Hey, we don't really know yet how people are going to put these together, but we know that we have approved sort of policy and configuration for PostgreSQL and Azure Container Apps or something like that, right? And then bringing them together may still be a little bit of an exercise to construct. So the dev is now able to go and do that kind of deployment, build, debug, inner loop against those, and then the publishing happens out into the pre-configured environments, following those policies and so forth, right? And using the combination of tools and services. You can use these directly from AZD. You can use them directly from, we actually have a portal, an Azure portal experience, and a secondary dev portal experience. More often we see these being really consumed from your pipelines, right? So you're really leveraging your CI/CD environment to spin these up. And that's also where we'll see a combination based on your application needs of, the granularity. Maybe it's always a tear down rebuild. Maybe there's some shared infrastructure that you keep around in the dev environment just for cost savings. But you can now get to a point where you can literally on a PR request basis spin up as much of that infrastructure as you want to support that PR, to support the testing of that. If everything is good and everything is green, you could tear it right down, right, as part of the merge. If things fail, you can leave it up. So there's a repo environment available for folks. So looking at that, that kind of brings us back to the beginning of like, well, how do we think about these layers, right? And so at the base, you have the core engineering system components, right? What are your dev tools? What are how are you doing collaboration? How are you doing CI/CD? You then have the runtime environments for those applications, right? The application platform, the runtime, the security governance, the observability operations, and then you can get up into the layers of these templates and starting to get into even like application patterns and those kinds of things. Again, inside Microsoft, we're mostly in the bottom 2 layers today, with a few little exceptions. Customers that I work with, I see sort of all, across the board. I will say, and this is not I'm not trying to be judgmental on anybody, but a thing that I've seen happen a little more often than not is if you start too far up on the top, adoption gets hard because it feels too constraining, right? If it's like the only way to deploy an API in our organization is to use our pattern top to bottom, that feels, as an engineer, that doesn't feel great, right? It also tends to lend itself to being a little bit monolithic, where you can only, if you want to do anything, you have to take the whole thing because they built it kind of the wrong direction. And so those are some practices that I've found tend to work. If you start from the bottom and kind of construct up, that also tends to mean you have a little bit more of an independent composable platform, so that when something new comes in, you can easily add it in and collect versus like, oh, I got to take this whole monster, even though I really just needed like this thin slice of it. So same thing, different view, but then we layer in the things that really make this kind of self-service for the developer. So what are the challenges you have to think about here? Well, one of them is the identity of the developer. Turns out we don't have great identity collaboration across all of these things, right? So that's something that needs to be thought through and worked out. Okay, we need to orchestrate across all of these different tools, right? We need to orchestrate that from a provisioning and a deprovisioning standpoint, from an onboarding and an offboarding. When you get into collaboration, or reuse, okay, how do I know what's there, right? And how do I consume it? How do I have visibility into how our teams are actually working and operating, right? That's where a lot of those metrics that I talked about before, this is where they can get implemented. And then what's the actual experiences, multiple, plural, that we want our developers to have, right? How do we create these, how do we create it? The best, most adopted engineering platforms that I've seen show up where the developer is, right? I hear often, and I do sometimes hear and see a tight coupling between platform engineering and internal developer platform or internal developer portal, right? Portals have a role, no doubt about it, but I don't think they're the only way, right? That you can interact with your engineering platform. Inside Microsoft, we have a portal. It's a pretty uninspiring SharePoint site, which is kind of amusing that the company that builds SharePoint doesn't really know how to use SharePoint. So it's essentially a glorified wiki with a bunch of links of off to things. Most of the use of our engineering platform inside the company comes from experiences that we have built into the other places the developers already are and already are working, whether that's extensions in the command line, extensions to the tools. Most of it is through extensions and custom, or not custom, but like specific implementations of the CI/CD experiences, right? Because that's where the developers already are. Okay. So let me show you a couple demos of how we could approach this. So let me set up the first one. So the first one we're going to look at, imagine an engineering team that is working on a kind of e-commerce web-based experience, so the web retail experience. And they've already got that stood up. That's been out there for a long time. They're on the generative AI wave, so they've been asked to go integrate a sort of chat experience into into the website for doing recommendations and stuff like that. And so they've done that. That's there. And now it's starting to take off and starting to get a lot of usage. And now they're going to start struggling with, well, how do I go continue to modernize and advance this and bring on some new capabilities that, as an engineer, maybe I'm not familiar with.
On the eShop application with Shane, and our app has gone bananas. It's really grown, and we've gotten to the point where we need better visibility into our OpenAI usage, and we're likely going to need to scale to another region and add another OpenAI instance. Now, that's a lot of complexity, and I'm not really 100% sure how to do that. My platform engineering team has written a Copilot extension. I'm going to go there first and see if they've got anything that can help me get started with this. So the first thing I'm going to do is ask my question if I can get better visibility and metrics. Now, the Copilot extension that my platform engineering team has written is really tailored to our organization, our best practices, our opinionated stacks, and our requirements. And so it's likely that our platform engineering team has created a template or some way for me to get started as I, to figure out how to manage and work with OpenAI a little more effectively. And so I can see I've got a template right at the top that says enable standard OpenAI configuration. And if I look at that template, it says it's going to help me load balance across multiple instances of OpenAI. Sounds exactly like what I would like to do. And I'm going to get better metrics and visibility by onboarding into the APIM GenAI gateway capabilities here that our team has adopted. And it has to update, some information in my repository, open key and endpoint. Shane's already set that up for me, so that's good to go. So this all looks really good, and I think that's the one I'm going to go ahead and start with. All right, great. So now it's going to confirm that, hey, do you really want to do this? And this is because it's, going to onboard a new endpoint inside of APIM for me, and it's going to update values in my repository. So it's going to ask me, are you sure you want to do that? And yes, I am. Okay. Now it's going to look and ask me for some information that it needs to properly onboard me into the GenAI gateway capabilities of APIM. And it looks like I've got some load balancing enabled. That's great. Some default token metrics, and it's already picked up the repository of my application. So all that looks good, but I'd like to know a little bit more about what the default token metrics are. I'd like to see what I'm going to get here. So I'm just going to ask it to explain what the default token metrics are. And let's see if I can learn a little bit more about what I'm going to be getting as I get onboarded into this. And what's great about this is I don't have to troll through a wiki. I don't have to find the right person in email. I can simply ask the Copilot extension. It's going to look at that information that it has, and it's going to come back and tell me exactly what these things are. And it looks like I'm going to get tokens that are used for API, per operation, and per the gateway. That all looks really great. And I've also noticed that I can get actual user ID token metrics too as an optional thing. I'm going to turn those on. So I'm going to go ahead and say that I would like to get the user ID token metrics. Now all that looks great. I'm ready to go. So I'm going to go ahead and submit that. Let's just see what happens. So now I've told the Copilot extension, take all that information, pass it over and process it, and let's get myself onboarded to the APIM Gen AI capability so I can get load balancing and metrics. And that was all I had to do. I didn't have to troll through wikis. I didn't have to email anybody, and all of that was done for me. So that saved me a lot of time. Now let's go look and see what I ended up getting. So here inside of APIM is the new endpoint, are the endpoints that have been onboarded. And this one runs pretty quick, and we can see that here's my eShop demo application that we just created. And here's my repository of my application, and here's my old API there. And if I refresh that, I bet I'm going to get a new API in here. I bet I'm going to get a new API in here. Yep, there it is. I just had to refresh it, and you see that happen for me right now. And there really shouldn't be a lot of change to my application. So let's just see if it can recommend some goggles. So now I'm using the application just like I did before. Everything looks great. And if I hop over to App Insights, I now have a dashboard that's tailored for my application. I can now take the token metrics that was enabled for me but through the APIM Gen AI gateway, and I can put them on the same dashboard as my operational metrics and really get a good view of how my application is responding to chat requests. And that's it. I didn't have to do any trolling of wikis, no emails, no nothing. It was all done for me through the Copilot extension that my platform engineering team has set up, saving me lots of times. That was super slick.
So obviously we saw a number of things there. The thing that, a few of the things that I think are really compelling about this is that it illustrated how we can bring these platform engineering experiences right to the developer where they already are, and we can leverage the context that we already have about what the developer is working in, so forth, right? So we were able to go create an experience that, because Mark, in this case, one of my peers, was working inside of the project, inside of VS Code, we already were able to discover the context in which he was trying to work. We could discover the repo, we could discover those kinds of things, right? Without him having to go and provide all the information to us. Mark was also able to go and approach this potentially, well, to him, complex task, because he didn't have any knowledge about how these worked, right? Right from in that environment, he didn't have to go try to figure out, where is this information at? Who do I need to talk to? Which pieces of the information that people are providing to me are relevant to what I'm trying to do? That's one of the things, that I find really compelling about this is portals are important. They have a role, but one of the struggles with every portal implementation I've ever seen is that they're authored from the perspective of the owner of the content of that portal. So the security team authors security-related guidance and stuff from the perspective that they have of what's going on, right? The API gateway team's going to do theirs, and so forth. As an engineer, as a developer working on a task, not only do you have to know all those portals, but you got to parse through and figure out which of this information is relevant to what I'm trying to do right now. Turns out, Copilots are pretty good at that, and are able to go and do that. Now, one of the things, a couple of things you saw there, well, you didn't see because it sort of had happened behind the scenes, is the developer identity was already kind of handled, right? So it knew it was Mark, and it knew Mark from the context of both his kind of Entra identity as well as his GitHub identity. And that was done by an initial upfront kind of sign-in process that ensured those two things were related. It understood that, as part of the project context, it leveraged deployment environments to understand the context of templates and infrastructure that is available to Mark in the context of this project. So it was able to find that Gen AI gateway configuration and things like that. So really, really productive. I will also share that I've had the opportunity to talk to a number of customers in the space recently, and I had a thing that my gut told me would happen, but I actually got to observe it. So there were 3 customers right around the Build conference where we had an opportunity to have this conversation and show some of these demos too. In each of those instances, they shared with me up front that, hey, one of the things that we're working on right now is figuring out what our internal developer portal technology is going to be, right? So, is it Backstage, is it blah, blah. And in the room was the individual whose job it was to figure that out and maintain it, or run it. After seeing that demo and us saying nothing, right, they all ended up in a place of, I'm going to completely rethink the scope at which I'm approaching the developer portal from, because it still needs to be there, but they need to think differently about the scope of how they're going to implement it and where they're going to prioritize the experiences when they saw something like this, right? Which was cool. It's cool to see people's kind of eyes opening. Now, fun little thing. So again, I've been in developer tools for a long time. So I remember the day when you hit the dot and like statement completion IntelliSense started coming up. I also remember many times doing the user studies, like behind the mirror, watching people do this. And it's amazing how even when that shows up, how many developers would still continue to type it when they could have just completed it. And how often, even with it showing as ghost text, essentially, they mistyped it, right? And now what I'm seeing in kind of the Gen AI world and the Copilot world is developers not being confident that if they mistype a word, Copilot will still figure it out. So you see, it's a pretty universal thing that I see. Turns out it's probably a good thing at this point because they still are a little iffy. But at some point, like, I encourage you as you're playing with it, like just every now and then try. Like, did I have to nail the spelling correctly, or would it have figured it out? Okay, so that's a bit about the experience that we can provide. In this next kind of demo, what we'll take a look at is, okay, well, how do we go about actually doing that? What was the experience of the platform engineer to go introduce something into the engineering platform and then have it be visible or exposed to the appropriate sets of developers in the team?
Behind the scenes look at how we enabled our developers to self-serve that onboarding experience into the APIM Gen AI capability. Now, as a platform engineer, I live and die with GitHub Actions. I mean, they're key for me to be able to scale out automation across my estate. And so I want to be able to take that investment that I have in GitHub Actions and expose that through the Copilot extension that we've written. And that's what we've enabled here. And so to do that, there's really only 2 things that we need. The first thing we need to do is have a repository that has been annotated to indicate that it contributes workflows to the Copilot extension. And then we need some workflows. So the first part's really easy. Here's a repository, and we've done this through a custom property that says this repository contributes workflows into our Copilot extension. Next, all we need is a workflow. And we can create one of those here, and we've got a start right workflow template all ready to go. And let's imagine I'm just adding some chaos testing here. So add chaos testing for key vault deny access. And down here, I can say that, here we go, this workflow will be used to deny access through Azure Chaos Studio. Deny access, let's see, to your key vault. And when I commit those changes, it's ready to go and be used through our Copilot extension. And it's really that easy. So let's hop back over to our repository. We'll start a new chat with Copilot, and we'll say at Contoso ES, how can I test my key vault? And just like before, it's going to look across the set of automation templates that we've created, It's going to look to see if there's one that's a good fit. And if there's one that's a good fit, it's going to recommend it for me. And there it is, the one we just created. And I can walk through that standard submission flow that we did before. That's how easy it is to take the existing automation that you have in Copilot, existing automation that you have in your investments in GitHub Actions, and expose them through the Copilot extension.
So pretty straightforward, right? Now, again, the power I see here comes from a number of aspects. One, it's leveraging the DevOps platform and the DevOps tools in a standard way, right? So in this case, it's just annotating, it's just GitHub repos using, actions, tags, and so forth to denote that, hey, this is something that we know about in the platform as a workflow, something that can be provisioned, right? Standard, infrastructure as code, standard markup, or YAML, those kinds of things, right? The other thing that this shows is the multi-channel, I'll call it the multi-channel experience, right? So the Copilot can also show up everywhere that you need it, right? So in this case, we saw it before within VS Code. We're seeing it here within the context of GitHub, right? So both, an engineer that may be trying to do something that's more related to the work they would be thinking about doing inside of GitHub, they can just invoke it right there. The platform engineer can use it and test within that. So I think the other powerful aspect here, thinking about the leveraging the platform, is now when it comes to actually configuring, the roles or who can do what within your engineering platform, who can contribute, what level of contribution, those kind of things. That's all just standard kind of GitHub, user authentication, user security, user configuration that you're doing, right? Nothing super special there. Okay, so what we didn't show is a little bit of kind of the architecture, for lack of a better term, of how we're thinking about enabling platform engineering and platform engineers and these experiences from our perspective. Again, leveraging and building on this notion of it is a practice more than a product. We have a lot of ingredients here that you can leverage, right? As part of your engineering platform, but we need to bring them together. At the end of the day, what you're doing when you're creating an engineering platform is you're looking to codify your practices, right? You're looking to go and take those points of view you have and those opinionated stacks and codify them in a way that's easy for engineers to work with. You then want those opinions available in all of the experiences that the people that need to work with the platform, right, from an engineer to an ops person, are going to be working in. And so for us, the way to do that is to put it behind an API. And so we have this notion of the developer platform API. There's a potential implementation that we'll probably start sharing as a sample really soon. We actually call it the Developer Self-Service Foundation right now, but it's the same idea, right? Which is that kind of orchestrator, it is that API that can be consumed by all of the different experiences that you want to enable for your developers or your operations folks. So whether that's an IDE extension with something like VS Code, whether that's a portal with something like a Backstage or one of the others, whether that's the command line experience, or whether that's a Copilot based experience or extension. Our focus right now is primarily starting with the orchestration aspect of it, right? How do we provision and deprovision things? That we feel is the entry point here. That brings it with it, starts to bring with it the catalog, the inventory of what's been done and what's available, upon which we can then build the experience for like monitoring, diagnosing what's going on. The platform API, its construction experience is by pulling together a set of providers. And so you can imagine that as Microsoft, we will have a set of providers that we will just make available. So things like Microsoft DevBox for your cloud-hosted developer workstations, code spaces for your cloud-hosted developer workspace, your container-based workspace, API Center, the Dev Center deployment environments, GitHub Actions, ASDO projects, and so forth. But this is where we're hoping and going to be pushing on getting an ecosystem of these across the development and development service providers. So think about whatever you're using, right? Either they've created the provider that can plug in, and then you can create your own, right? So if there's a tool that you have or some internal process or internal tool that you have and you want to plug into this, you can create your own provider to plug into this. And now, it just lights up in that developer platform. All building upon kind of those core underlying pinnings that you had, right? Make sense? From the Copilot standpoint, right, you think about it as we literally just built a Copilot extension, right? So we're bringing in, the prompt and stuff from the user. We are kind of grounding that a bit in your engineering platform. What catalog of content do you have? Workflows, samples, APIs, whatever the providers have. So essentially, we can go in and sort of through the API say, hey, we have this request. What providers can play? And then that kind of incorporates in with the, oops, let me back up. Not really, go back. Yeah. And then kind of leveraging the foundational models for what they're good at. It's kind of fun when you start playing with these kinds of experiences, because you first start to find the balance of what's the LLM good at and what should you just code, right? Because you don't really need to go ask that to generate it. You know what those parts are and you can actually head it in the right direction. But then I think back to that first demo, right? One of the real cool places is like, okay, we want to go and expose these templates and these opinions, but hey, as the developer, if I want to learn more about what that is, now I'm just going and having a direct conversation, right, with the LLM about what is this thing, right? What does this value mean? And those kinds of things, right? So all of this builds upon the work that the GitHub team is doing in this space. So bringing us back to our first sort of example of, customer, right? In that multi-week journey that they went on to try to figure things out, right? I think with the experiences that you just saw, right? And the potential there is now we're getting ourselves to a place where your platform engineering team can codify the points of view, the guidance and so forth. We can expose that through a developer platform, a developer API, make it available to the engineers, development leads, architects, whatever role within your organization needs to do these things, to discover them, self-service provision them, right? Spend less time doing that work that they, quite honestly, often don't want to be doing. Most often don't already have the knowledge to do, so have to go do a bunch of research, and be able to more quickly get back to doing what it is they're trying to do, right? Where they're bringing the unique value, these things. And so the ingredients that we've talked about, we've talked about the Dev CLI, we talked about Azure deployment environments. I didn't spend a lot of time talking about things like GitHub code spaces or Microsoft DevBox. We see those as also critical when we think about the motivations and the developer happiness, right? Those critical workflows. The fact that the GitHub team, I think it's still under 40 seconds, can onboard a new engineer to GitHub, the core, in less than 40 seconds because they're using code spaces. A number of the teams within Microsoft are using Microsoft DevBox for their more complicated projects. So a lot of the folks in M365, SharePoint's my favorite example. If anybody's ever done SharePoint development back in the day, knows what it's like to configure and set up SharePoint. Imagine being the person who's trying to actually build SharePoint and configure that. That was a very lengthy process for them. They've got it down now to just under a minute of human interaction time to go request the dev box. It takes a little while to spin it up, but they know they've got it and they know they've got it working for them consistently. By the way, that turns out that's an experience that inside Microsoft, we have about 25,000 monthly active users of Microsoft DevBox right now, and it's been an entirely opt-in experience. We have not forced anybody to use it yet. It's all been teams deciding that, hey, there's value here in getting my environment quickly, getting it consistently, and so forth. And obviously, GitHub Codebase is similar motivation. I think with that, I will, well, sorry, the obligatory. Microsoft loves developers. And for kind of follow up, Eric pointed you to the first one this morning. The second one, there's a Microsoft Learn site, which essentially is a whole documentation set on our kind of point of view on platform engineering and the journey and so forth. So if you really want to get in, there's lots of content in there that you can look at. Cool.
Thank you.
Awesome.
Thank you very much, Jay.
Thank you.
Cool to see how we do stuff and how we share what we do for ourselves to you as a product or a service. Know that we done the job for Microsoft. We will do the same job for GitHub with Alain. Please welcome again, Alain.
All right. Hi again. Yeah. Thank you. So I just wanted to show you basically what we're doing at GitHub when it comes to platform engineering, and I just want to show you how our developers are working. I've been doing that over the years. Maybe it's not the first time you see me presenting how GitHub does GitHub, but it's keep changing. So it's even if you've seen that a couple of years ago, it will be a different story today. So you might remember a couple of years ago, that was GitHub. Anybody remember that? Did you have an account at that time? Yeah, a couple of people. So GitHub is 17 years old company now. It's quite older than what we think, right? It's been there for quite a while. So that was our website, right, like 10, 12 years ago. But I wanted to go even further back. As you can see, the first commit or the first push rather was on October 20th in 2007. Actually, the company was founded in 2008, so a little bit later. But yeah, so that was 17 years ago that we started writing the code of GitHub, and a lot of change. A lot of things have changed, obviously, during that time. So we created a full platform. You know, at that time, GitHub was just a bunch of repositories. And a couple months later, we announced that we created the pull request. You know, that was the main feature of the website. And since then, you now have Copilot, obviously, but GitHub Actions, GitHub Advanced Security, Code Spaces. I mean, a lot of things have come to the platform. So it means that now the team is like a lot bigger, but we're still working in that repo, GitHub, into the GitHub organization. So it goes github.com/GitHub/GitHub. So we call that GitHub. That's where we're working. And that's what it looks like, basically. So you see that over the 17 years, we had 1,545 contributors. A lot of people. I mean, some of them are no longer with us, obviously. But on a day-to-day basis, you probably have several hundred people contributing to the repository. So how do they work? So a couple more figures before that. So we know that what we're looking at. That's 1.7 million commits. Of course, 17 years, that's a lot of commits, so that's fine. Things that we are not necessarily very proud of is the number of branches we still have. There's a lot of cleanup to be done, obviously, but nobody has that time. So we'll keep it that way for a longer time, but yeah, there's definitely some improvement to be done. Deployment. So deployment is cool. So you have here the couple environments. So you have a lot more environments, obviously. But as you can see with the orange circle, we are currently deploying in production. And actually, that circle is probably orange like all the time because we always deploy to github.com. So we've always had that way of deploying, to production without any downtime. And the way we're working is that, a developer, as soon as they are ready, as soon as they have finished a pull request, it can go to production right away. And I will show you how it works. But we've always said that the only real test environment for us is production. So we push the production to test, and then we release, or like we open up the gates of the feature when we are happy with that. So I'll show you how it works. So it all starts, in order to, make our engineering team is roughly 1,000 people. If you count everybody, like, developers, but also ops and, all the kind of roles you can have in such an organization. It's critical for us to have a good developer experience so that people can join the company, can join our engineering team and be productive very quickly. That's something that we are really passionate about. And we are in an ecosystem that's always changing. So how do we bring all these changes to everybody without impacting all our developers all the time? So the developer experience is super important, so that we have a team for that. They call it the DX team. And they really consider their job as, or like whatever they're delivering, as a product. So they communicate with the rest of the teams. So they have a newsletter every month, and where they are advertising everything they've been doing, like all the changes they've introduced to all the developers. You see, as you can see, they have a developer satisfaction, DevSat, developer satisfaction survey. So they constantly poll all the developers internally to understand, what's blocking them, where could they improve, how can we make their life easier? Because that's the main goal, right? To make, all the rest of the engineering team's life a lot easier so they can be more productive. So, and they're delivering a lot of things. So I'm not going to go through that stuff, but every month they come up with new improvement. There are probably about 10, 20 people in that team, working for the rest of the company. So very important team for us, and one of the main product that they deliver is a developer portal. So that's the entry point for everybody to use all the features that they need on a day-to-day basis to deliver features. So as you can see over there, you have the feature flags. You got we're going to look into the production timelines. There are the engineering docs. Lots of different things that are available, so that we don't need to go in many different sites to understand what's going on or where are the resources that we need. We go there, we find everything, and then we can start working. So for instance, if we look at, I think the production timeline to begin with. So it's always good to understand what's happening in our world. So, we have hundreds and hundreds of production dashboards, but it's hard to understand whenever I have an incident, where it's coming from. Like, it's critical for us to be able to understand what's wrong and what happened before something goes wrong. So we have that production timeline where we see basically all the deployments, through our infrastructure, and it's very easy to understand. Like, if you look at the bottom on the right, so what was the pipeline that generated that event? So if I have something broken in production, anybody can just click on that button and see the logs of the GitHub Actions workflow that generated that deployment, for instance, but also get all the issues that have been captured from that incident or from that event if we need to diagnose that. So not having to access like 5 different systems to understand what's going on whenever there's an incident, making that easy, because that's when I need the most streamlined process. That's not when I have an incident, I need to start figuring what my password is for the production log and for the dashboarding stuff. I need to get access to all that stuff right away. So this is one of the tools they have, and it's like super efficient and super useful to get access, to get that streamlined view of everything that's going on. Another tool that we have that's very interesting also is to declare incidents. Whenever you're seeing something is wrong, you can declare an incident. It could be an internal one, it could be an external one. So when you go to the GitHub status page and we're telling you that we have a problem, That's where it's coming from. I mean, that's one of the channels where it can come from. So it could be a good way, when I'm seeing something here in France, sometimes, we might have some problems because of one of the network layers or like the CDN or whatever that my colleagues in the US might not see. So I could use that site to say, I'm seeing something wrong over there. Like, please help me. So that's another part of that portal. And then one of the main component of our ways of creating product is a service catalog. So, we have, again, 1,000 people in that engineering team. We have many, many different products, so many, many different teams working, in silos sometimes, but they need to connect as well. Maybe in your companies you have, implemented SAFe, and I'm sorry for you. We try to stay away from that kind of stuff. So we decided that in order, instead of like having that like cumbersome methodologies, we're going to create tools so that people can help themselves and can self-organize as much as they can. So the service catalog is a key component of that. So every major feature of GitHub is a service, basically. So you get the GraphQL API, the REST API, the pull request is a service, code spaces is a service, GitHub Actions is a service. Like these all these big features are managed by different teams, even though you all access them from the same, github.com page. But for us, it's different things. So every service is listed over there, and you see a bunch of information. This is like the main dashboard for all our services. And for instance, you see who is a team over there managing that, who is a product manager, where can I find the channel where I can talk with these people if I see something wrong as well. So, that's my entry point to all this ecosystem. So again, if I have a question about pull requests, I can go to the service catalog, I can see who I need to deal with, and I can take it from there. So if you're not in the service catalog, it means you don't exist. Like, it's not even like you're not in production. It means like nobody's working on that stuff. It's not a thing at GitHub. So it's very important to be listed over there. And if we zoom into one of the services, so I picked up the GraphQL API, you see several tabs over there. So we're going to go through a couple of these tabs so you understand what's going on, because it drives a lot also the way we're working on a day-to-day basis. So the first one here is the scorecards. So the scorecard is super important when it comes to platform engineering, because as we said earlier, you get a state of your platform now, and that state is going to change over time. So you're going to introduce more things, for instance, more requirements or like more security guidelines, a lot of things. And how do you distribute this task to everybody so that everybody stays, everybody in my catalog applies these rules, over the time. So at their pace, but still I need everybody to be compliant. So for that, we've created these scorecards where over several dimensions, we're telling people what we are expecting from them. Like, you need to have, encryption, you need to have security, you need to have logs, you need to have monitoring, all these kind of things. We need everybody to have them enabled. And sometimes this requirement, as I said, will change, and we will give you time to adapt to that. But we will track that with that scorecard. So with the scorecards, we can understand whether everybody is compliant with my new set of guidelines in my company. So it's super important. It gives a way to tell everybody what you're explaining, when you're explaining that, and are you compliant or not, so you can keep track of that. So that's the scorecard. Here we're seeing also the actions items. So whenever something is not compliant or there's been an incident, we always have some follow-up task. So it's okay to have incidents, but we have a process to make sure that this incident will not happen again. So we get learnings, and with these learnings, we have actions, and we distribute these actions through that portal. And so we can track whether people have, have adopted this recommendation or this task that we have given them, so that we make sure that in the future we don't have that kind of stuff anymore. The other thing is like support channels. So you can also see, each service will be able to expose the different channels of communication based on the severity of the incident and what their SLOs to respond to this incident. So you can see like if I have a severity 1, I will respond in 30 minutes. And this is how you can trigger that call. So you get that pager duty command. And so you can go to our chat, to our chat, any chat channels actually, and trigger that paging system, and the first responder will be automatically notified, and it will be able to work on that. You can also trigger that with that button, and we're going back to that page we saw earlier. Then if you have severity 2, you can create an issue in that repo. So every team has their own repo. That's not where their coding is happening, that's where they are organizing themselves. So in these repositories, so for instance, the ecosystem API repository, you don't have any API code. You have like markdown documents, you have issues, you have like, it's like a collaboration channel. So it's our SharePoint. We don't use SharePoint, we use GitHub repositories, but all our collaboration is happening over there, basically. Severity 3, you go to Slack. Sorry, should not say Slack. You go to the chat, and that's where you are discussing with these engineers to ask questions, basically. Right, so let's move on. Dependencies. Each service obviously has dependency with other service. So that's where you can see these dependencies materialized. And you can understand, like, if I have a problem with my service and I have dependencies which have problems, maybe it's coming from these dependencies. So it's easier to understand whether it's a byproduct of another problem or you are the root cause of the problem. So it gives also a quick view of, this service is red, but all the dependencies are red as well. So, problem might be somewhere else. So I don't need to bug these people because most likely it's coming from a third-party system. So dependencies can be deep. We have an automated way of looking at that. So this is a graph that's generated automatically, and so you can see that a lot of things can go wrong if one of the service on the right has a problem, because everything is depending on that. But it's great to have that map, automatically generated, so you understand what's going on in the system. You need to zoom, obviously, to make sense of that. But anyway. All right, so we've seen like the organizational part. So it's like more in the back office, if you wish. But now my developers need to create some code. Who remembers the number of commits we have? No? 17 million, yes. That's a lot of code, right? There's not a direct correlation between number of commits and number of lines of code or volumes. But just so you know, the GitHub repository, it's probably like 30 gigabytes, right? It's a lot, and if you take the development environment around that, it used to be like 40 to 50 gigabytes of data downloaded to your laptop, right? So for my colleague in the US, that was okay. For me in France, that was a little bit longer. And then you need to install a lot of things. So we had very well automated things. So with one command, you could install Elasticsearch, MySQL, Redis, and all those other components that I needed, and download a sample database as well. So after 8 hours, I will have a good environment working, right? And probably in a month from now, it will not work anymore because we will update something, or I will break something on my laptop. We're using Ruby, so anytime somebody is playing around with the Ruby environment, everything breaks right away. So we spent a lot of time and a lot of energy automating that stuff, but it was not error prone. Like, there were a lot of ways to break that stuff. So we had other automations to try to fix the problems as well, but they could break as well. So that was not great. We decided to solve that to use code spaces. All right, so our full engineering team now has migrated over to code spaces, except for the ones who are developing the iPhone and Android apps. Maybe Android they can, but iPhone they can't, unfortunately, use that. But for the rest, everybody's on CodeSpace. So now we know that green button over there, instead of saying git clone, I can go over there and say that I want to create a new code space on master. Click on that button, or I can configure that, and you can see that we've decided that our developers could use 16 core code spaces or 42 core code space. Right, that's, we have a big stuff. I'm going to show you basically the number of processes that are triggered every time I'm running a local instance, but it's pretty big. So we need at least 16 cores. And once I do that and I click on start, and I click on the clicker, you have that code space starting. So I got my VS Code here, and you see all the different processes that are available. So it's 35 different processes listening to the network. 35 that I would have otherwise, needed to run on my machine. So that code space, once I click on the create code space on main button, I got it in about a minute. It's like if I was giving you a brand new laptop in 1 minute, and you can ask for a new laptop 10 minutes later, and then another one 10 minutes later. As much as you want, you get new laptops, right? 42 cores or 16 cores, or you decide. But it gives you instantly an environment where everything is pre-installed. I don't need to do anything. I don't need to install Ruby on my machine. I don't need to install MySQL. I don't even need to have VS Code, because I could use VS Code in the web browser. I prefer to have the the client, the native client experience. So I can do that. That's what I've done here. But other than that, I don't need anything. So it's pretty cool. Starting right away. In the background, what happens basically is that we are preparing these code spaces for our developers. So because they take a long time to build, so we build them ahead of time. And so we always have maybe 10, 20 of them ready to be given to developers. And when I click on create a code space, actually we're not creating the code space because it's already pre-built. We're just refreshing it. We have already done the git clone on that machine. We're just doing a git fetch, git pull, and that's it. So whatever is missing from the last time we created this code space is coming. So that's why I can get such a big machine in 1 minute. So you can do that as well. I mean, everything that I'm showing you right now is available to everybody. You can decide to pre-build these code spaces or to just build them on the fly. Then it's a matter of optimization, from a cost and time point of view. So, but it has changed the way we develop basically at GitHub, because you can also break everything. Like you can make crazy experiments. You don't care, because again, you can recreate a code space right away. You can expose this port. So you can say to a colleague, hey, look at my version that's running on my machine. And so that you can make, for instance, my web port. I can share public, so this is set to private, but I can decide to set it to public and share it with somebody. You can send a link and they can see what's going on your code space. Not on your machine, because it's not in your machine, but somewhere else. So it's super easy to do that as well. Okay, let's move on. Yeah, so then I can start my local machine. As you can see, I got a GitHub on 127.0.0.1. So that's in minutes, I can go ahead and start tinkering with my local version of GitHub and do whatever I want. I got all my tasks in VS Code already populated. So I picked up the run server one, and it started that. Actually, the longest time is actually to start the server, not to create the code space. All right, so we've been coding. And as I said, at GitHub, we like to use the production environment as our test environment, right? So a feature is not shipped until it has been tested in production. So I have to put it in production first, and then I can say, hey, this is available. You can now use it. We decorrelate basically the act of deploying to the act of releasing to our customers. It's two different things. And so in order to do that, we use feature flag a lot. And we've been using feature flag for like I don't know, 12 years, 14 years, so very early. We actually created our own internal framework. It's called a Flipper, the dolphin Flipper. Yeah, and it's available. It's open source, so you can use it as well if you want. But it's heavily skewed towards Ruby. So if you're not using Ruby, you won't be it won't be very useful for you. But so feature flag is very important, and we use it that heavily. So as a new developer, I might want to know how to use feature flags at GitHub. And so obviously, to make things easier for our developers, we've been using Copilot Enterprise. So I think that was something you showed already, Jay, earlier. So with Copilot Enterprise, we have the concept of knowledge bases. So we created a knowledge base for our engineering documentation. And so that a developer can come over there and ask a question. And Copilot is going to provide an answer tailored to our documentation. So it's not something that anybody else on the internet could find. It's something that's based on our internal documentation. So that's what we have here, for instance. I'm saying, hey, how do I create a feature flag at GitHub? And this is, a documentation generated based on Flipper. So I didn't have to tell Copilot that we are using Flipper. Copilot knows that. And that's, how you inject a feature flag into our configuration, into our code. So now you have your feature flag. You can start playing with that feature flag. So you can, you have that code that's released to production with that feature flag, and you can decide, in a separated way, who is going to see the code that's behind that feature flag or not. So back to the developer portal, we see our feature flag that's called Copilot Workspace, and you see the green staff sheet label. Staff sheet means that all the employees at GitHub have access to that. When we release things, we first go through that, first circle of people, the GitHub employees, so that we can get feedback. And then later, we can augment the rollout of that feature. For instance, here, you see the actors. We have 57 actors being able to access that. So on top of the GitHub employees, you get 57 people on GitHub who also have access to that feature. And we can play with the number of people, the percentage. It can be random, it can be very well controlled. We can with that we can really decide how much of that feature is going to be exposed to our users and who are these users basically. So it's super convenient to make sure that when we have for instance a beta program, that's how we are going to gate that beta program, and then we can make that we can onboard more and more and more people. So I will show you Copilot Workspace at the end, and there will be a registration page if you want to be part of that experiment. You'll be listed somewhere over there, and we can enable you with that UI. So super useful. All right, and then so I got my feature. I'm ready to push it to production, and we're going to the merge and deploy way of doing that. So here I picked up a pull request that's touching a lot of different components in our website. So it's one of our core UI framework. It's called Primer. It's open source as well. If you go to primer.github.io, you'll be able to use it. And as you can see, because it's very central, a lot of teams are being notified about that change. So it's creating a lot of noise. And we need to have all these people accepting that change. So this is very unusual, but I thought that it was pretty funny to see that many teams involved in one little change. So you'll be able, very important part. The way we are managing our pull requests, we make sure that we go through a template so that you always find the same kind of information. And if it's going to touch production or not, you understand the risk, you expose a lot of information so that people know what to expect when they're reviewing, and you make sure that if it's very important and very sensitive, people are really engaged during their pull request review, or they can give you a pass easier. So once this is approved, I get a bunch of checks running on. Once you go out of the draft mode, you get lots of checks going on. As you can see, So this is our CI getting triggered. You see we have, I need to do the math, but we have more than 210 different checks on every single pull request. So 210 jobs somewhere, crunching that pull request, making some tests, and sending feedback to the developer. Our goal is to get a feedback in less than 20 minutes to the developer, so like lots of parallel CI jobs, but we want to optimize for the feedback loop for the developers. We want developers to know quickly whether something is good or not, and we don't want them to say, okay, it's going to take an hour, so I'm going to walk the dog or doing something different. We want to make sure that they know that you can grab a quick coffee, but they can go back to that quickly and stay in that flow and not getting distracted too much. So that's a lot of checks, and that's part of the platform engineering team to craft some of these. Obviously, developers create their own unit tests, but the running part of that, the platform engineering is managing that. It's a lot of CI jobs, so we, the Azure team is getting a lot of credit from us with all that workload running over there. Right, so we have that, and what happens is that then we are enqueuing that pull request. I mean, that execution of pipeline is part of the of a merge queue. So anybody is using the merge queue? Does that ring a bell for you? No? The merge queue is what we created when we have many different teams or many developers basically trying to merge at the same time in the same repository. Because think about that, all these processes that we're doing. So like a developer comes, open a pull request, you got all these jobs created, and by the time the CI has finished, somebody else has already pushed or merged a pull request. So your branch is not up to date anymore. And you might have to come to solve some conflicts. While you solve some conflicts, you have the CI jobs running again. And by the time they finish, somebody has already pushed another pull request. You have some conflicts, and you have to redo that over and over and over again. So that's not a situation where you want to be in. So with the merge queue, we make sure that developers can deliver quickly. We pile the pull requests, and we manage that queue, so we avoid some of these conflicts, basically. All right. So you see here, the top over there is a very small queue, because I took that picture in the morning in France, so there are less developers working. But if you come later during the day, like when people on the Pacific time are working, you will have at least 10 to 20 pull requests in that merge queue. The second one over there, the next queue, there are 2 in them, and then you will have more and more coming. So when I took that picture, it was a very small activity, but then you can get a lot more activity. So you see that merge group. So we are crunching, we are compiling every pull request, not compiling, but testing every pull request on top of the previous one, making sure they're always compliant and always compatible or without any conflicts with the previous one. So that was a needed feature for our developers. And we created that feature in the GitHub product, so you can also use that as well if you need to. If you have a very busy repository, that could be useful. And so this screen is the first one, basically. I mean, it's part of the developer portal, so that you don't have access to that. That's our own deployment portal. So that's where we see basically everything that's going on from a deployment point of view. So you see the pull request or the merge queue that we were releasing. You see that one on top. And that's the one being basically rolled out to production at this point in time. So that way we can see everything that's going on over all our environments. We see all the commits that are being released. We have all this information. Again, that's part of the developer portal. So our developer experience team created that. So it's easy to understand across all product, all environments, what's going on at a given point in time. If you zoom in one of these deployments, you see the internals of that. So when we deploy into production to GitHub, we deploy in phases. So we don't have 100% of our machines hit right away with that new code. We start with a few machines. We wait. We see what's going on. We have a little bit of the traffic going to that one. And then we increase the scale of the deployment, and then we wait another 10 minutes. We see again what's going on. Basically, we want to avoid, having too much of a blast radius whenever there is a problem in production. We want to make that as narrow as possible if we can. Overall, a deployment takes probably like 45 minutes, but a lot of that is spent waiting, waiting to see and monitoring to see if there is a problem or not in the production environment. We can monitor that in our chat as well. So all this information are always published to some channels. So if you don't want to go to the portal, you want to see that in the chat, you can do that as well. And you have all the links to all the pull requests and all the information. And you can click on that to see what's going on. Then that's for production. Sometimes you also want to be able to deploy to an environment for QA and testing. So we have chatbot comments. So these things, we've been doing that for like 15 years. Down the road, we're probably going to replace that by Copilot extensions. So instead of going to the chats, we could ask Copilot to do that directly. But we still have that used pretty widely. So for instance, here you see an engineer asking to deploy a pull request to me. That means to an on-the-fly deployment environment just created for me. Or it could be to the review lab, which is it's a less virtual, I would say, and it's an environment that's closer to what we have in production. So you can test other layers as well. So if you're just doing like a UI fix or something like this, you can use this virtual environment. If you're doing a deployment that's touching, the Git load balancer we have, for instance, then that virtual environment is not going to be useful. So the review lab is going to be closer to that, and you have these environments available as well. That's the only thing you need to know. Deploy these to review lab, and that's it. So think about, a new developer at GitHub. You have your code space. You can create your first commit right away. You're happy with that, you want to test it. You go to the chat, you have one command, that's it, done. So the time it takes for new developers to push a first commit to a test environment and then to production. For production, I just need to merge my pull request and then it goes automatically in the next train, and that's it. So think about that, when you're creating a developer experience team, that's the kind of experience that you want to create. Like, I don't need any internal knowledge to be able to, do all these kind of, day-to-day tasks, and I cannot mess it up. There is nothing I can screw up because they get so many testing and so many reviews on the way that I should not be able, unless I really want to do it, obviously, but otherwise it's pretty safe. Sometimes you want to prevent other people to deploying to production. So you have a special deployment, you get something very sensitive. So we have many more chat ops comments, that's what we call chat ops, to do things. So for instance, here I'm locking the environment and then I'm delocking the environment later. So during that time, I was able to isolate that environment from other deployments and make sure that I could do whatever I wanted over there. That doesn't happen that often, but like here we were testing the disaster recovery of our website, so we don't want to mess everything up at the same time. I think you understand that. So we have hundreds of these commands that you can use. And the great thing here is, these commands, they are in the chat window. So everybody can, see what's going on and learn from what we're doing. When we are working on incidents, we will use these commands as well. So for instance, if we have a new incident showing up, they will show up in the chat. Again, with all the links you need to deep dive in that, but we'll be able to start the conversation. So automatically, when we have such an incident, we have a new channels created, so that everybody who is involved in that incident can go and can discuss, because we have engineers across the globe. They cannot go in the same room to diagnose an incident. They have to go in the same chat room to do that. So that incident room has been created automatically. So you see June 20th. So I did that a couple of days ago, and you see the incident number over there. It's not going to tell you anything, but there was an intermittent breach due to a file server overload, and you get a bunch of people who are coming here, and so there is always a a guy who is the, or a woman, who is the incident commander, the person in charge of orchestrating everything over there. And it can automatically retrieve the name of the people who are, the first responders of each of the components that are involved in that incident. And then the conversation starts over there, basically. So that's what we've been doing so far. But we're looking at, how our experience and your experience to develop, features is going to change moving forward. So obviously, we've created GitHub Copilot for individuals. We've created Copilot for business. We've created Copilot Enterprise. So we've seen Copilot Enterprise quickly, how we were using that at GitHub. You remember the extensions as well that I showed you this morning, and Jay showed some example of the extensions. So we believe that these are going to be key components of how you're going to handle platform engineering moving forward. So think about Copilot Enterprise and extensions as a way to create tools for your developers so that they get access to knowledge, but also the full ecosystem of tools you have internally to be more productive. But we're looking already at the next phase of what we're going to deliver. And that's why we created Copilot Workspace. So we have a tech preview about that. Again, you can apply to be part of that experience. If you remember, I think it was a year and a half ago, I don't remember exactly when, there was a project called Copilot X, which turned into Copilot Chat. And so that's the same workflow basically we have here. So Copilot X was a technical preview, and the product was Copilot Chat. I mean, we created the product Copilot Chat later. So this Copilot Workspace here is a tech preview, and we want to share basically the vision of what we have in our plans. It's going to change. I don't know what the product is going to be exactly, but we're trying to think about the next experience when it comes to development. So you can apply for that, and what it looks like is basically think about a need that you have on a website, for instance. You want to change something, and most likely you will have somebody creating an issue for that. I think if I remember correctly, my video takes a lot of time to get started, or I didn't press on the button. I didn't press on the button. There you go. So I got an issue over there. I want to display the prices on my homepage. And I can open that issue in a workspace where basically Copilot Workspace is going to take my issue and turn that into a specification. So go a notch deeper. So Copilot is doing that and thinking, okay, you want to add price on your website. So these are the steps we probably should go through to add these prices on the website. And these are, overall elements of the solution, not detailed yet, but still a little bit more detailed than the requirement that I've expressed. So taking some business needs and getting an overall outline of what I want to do. So if it looks good, that's good. I can generate plan, but I can say, oh no, Copilot, maybe I didn't specify my need well enough, or maybe you didn't understand exactly what I needed. So I can create more items on that specification if I need to. But let's say it's okay. I can click on Generate Plan, and then Copilot's going to go deep into how do I go about executing that specification or generating a plan. And from that plan, I will go automatically to the code. So Copilot is going to generate basically that full code that's matching my business requirement. And where it's starting to be interesting when you start using that is that you start having that dialogue with Copilot about the full scope of that requirement. So until now, Copilot is really something that you're using for, a portion of a file, or a method or a class, or something like this. And here, you go at a much broader scope, and you start from a very, high-level expression of your need. And so you can always refine anything. So you can go back to your first step and say, no, that's not how I want to do it. So you can say, yeah, probably I need more details. And you can go back there, add more details, regenerate the specification, regenerate the plan, and you decide. Basically, you decide what's the right level of information you need to provide to get the right outcome. And anytime, anywhere, you can decide that if it's going to go, you can decide that you need to review some code. You can open that in the workspace or code space, rather. You can change that. And what we want to do, down the road, is to provide you eventually the execution environment attached to that workspace, so that you can test that live as well. So it's probably going to be, I don't know, 6 months, a year until you can put your hands on that. But we think that it's really the next level of experience that you're going to be able to get. Obviously, enriched by whatever your development experience team is going to provide to you. And I think that's it for me. So let's build from here.
Thank you very much.
Thank you.
For those who are online at the end of the live stream, so thank you again, Jay and Alain, for this morning. We can cut the line for the guys online. Yes. And for those pour ceux qui sont ici, on peut repasser en français. Donc nous avons maintenant le lunch. Lunch is not French.